All right. Looks like we are live here on Standing for Truth. My name is Donny, and I am your host and moderator for tonight's Great Age of the Earth debate. And it is a privilege to have Doc and also TRock to engage this important topic. I got to say, I am pumped. I am excited for a comprehensive debate on this topic. I know TRock and Doc have put a lot of work. They have prepped quite a bit for this exchange. They've both been here many times, whether it's open mics or formal debates. And so I'm excited what they're going to bring to the table for tonight. Specifically, the question we're debating is the Earth young or old? TRock holds to the young position, and Doc holds to the old position. So, gentlemen, why don't we get acquainted and break the ice a little bit before we get into the opening statements? And so, TRock, why don't we start with you? How you been, and also a little bit about yourself.
Quick mic check. Am I still coming in good?
Yes, you're coming in great.
Okay, awesome. Yeah, I have been studying apologetics for creation and the flood for, I don't know, 3, 4, 5 years. It's been a while now. I grew up in a Christian home. My parents did not emphasize young earth, old earth, anything like that. Very mildly, they emphasized not evolution. But other than that, we did not have a particular focus on the age of the earth or anything like that. So my parents weren't, very scientifically minded as far as how they studied and perceived things. Having said that, I'm going to defend the position tonight that the earth is approximately 6,000 years old, plus or minus a couple hundred years. And I look forward to the conversation with Doc here. So hopefully we'll just kind of be relaxed and so forth. I've been busy, so I got to apologize real quick. I'm not super well organized tonight, but I will get to share some information that I did not get to share in one of my previous debates due to technical difficulties with my connection at home. So hopefully that will go well. But I have been super busy battling entropy of all things. So I've been battling the mechanical thermal entropy as well as the biological entropy. So anyway, I'll turn it over to Doc to do his intro now.
TRock, I appreciate that introduction. If people want to see more from you, I understand you don't necessarily have a channel, but I do have at least one of your previous debates linked in the description box for people to check out. TRock, again, in light of how busy you are, I do appreciate you being here for tonight's debate. Okay, Doc, good to have you back as well. I think the last time you were here formally was your debate with Kent. And to anybody who hasn't yet seen that, I highly recommend they check it out. So, Doc, a little bit about yourself, a little bit about your channel, and also how you doing tonight. And then,
well, howdy. I'm Doc Dino, doing pretty good. As always, I do want to say that the Doc is a stage name. I'm not an actual doctor, at least not yet. That said, I have studied geology for over a decade now, and I do have a bachelor's degree in it. So I like to talk about rocks. Rocks, fossils, all that kind of stuff. TRock, some of his past debates caught my eye, and I was hoping to take a crack at debating it myself. So, hoping for a good night.
Can I ask you real quick, Doc, it's your intro, but can I ask you real quick, do you actually work in the field that you have your degree in?
Not yet. I am currently hunting for a grad school. But hope to one day work in a museum, preferably. But we'll see where I end up.
Okay, Doc, thank you very much for your introduction. I do see questions and super chats coming in already from the audience, and so I do appreciate that. I will be saving those for after the discussion portion and closing statements. We will be getting you guys in the audience involved. We will be having a roughly 25-minute audience Q&A. And so please, if you do have questions for TRock, if you have questions for Doc, do make sure to tag me either at Donny or at Standing For Truth. And that way I won't miss them. I do want to remind everybody as well that we only have 2 more debates until basically the summer of debates, as I've been advertising, is over. And so tonight, of course, we got the Great Age of the Earth debate. And then we will also be here tomorrow for our last debate in August. This will be between Carlos Xavier and Pastor Kevin Tremblay. Is the Holy Spirit the third person in the Trinity? And then after that, we'll be back here on September 1st. And so that is this Friday. Matt and I will be hosting. Matt will be co-hosting, co-debating with me. That'll be our next 2-in-1 open mic. And so I expect to see everybody there. As always, we have a ton of fun with those open mics. So, okay, I'm going to go over the format briefly for tonight. We've got 15-minute opening statements. TRock will be starting us off with his opening statement. Then we're going to jump into a fast-paced 5-minute rebuttal from both sides. Then a free-flowing discussion. So we got lots of time to discuss the topic, to ask each other questions, relevant questions to tonight's debate topic. We'll probably discuss the topic for about 60 minutes. Then we'll jump into some 5-minute closing statements where the debaters TRock and Dok can wrap up their thoughts and points. And then again, this is where we get you guys in the audience involved for an audience Q&A. Okay, let's get right into the fun, gentlemen. TRock, the first opening statement goes to you. 15 minutes. If you needed to screen share, do please let me know. And we'll kind of go from there.
I will be sharing screen. Let's see here. Let's see how I can do this. Okay, I think we're good to go. Quick word I want to open with. Paul Price did a talk with Donny on SFT here not too long ago, I think less than 2 weeks ago, on historical science versus operational science. And that was pretty good information you can get out of that. Paul does a real good job on that. So if you haven't seen that yet, I would recommend checking that out. But I'm going to give my very quick 2-minute version of operational science versus historical science. So the scientific method is a tool, and that is all it is. It's a tool. It's no different than a hammer or a screwdriver or any other type of tool that humans create for their benefit. So we're the masters of the tools that we use. They're not the master of us. But operational science is a really handy tool, but its best application has to do with studying the way the world works, present tense. How does the world work? How does gravity work? How does electromagnetism work? How does electricity work? How does heat and pressure work? That sort of thing. That is the best application for the scientific method and science in general. The scientific method is a very decidedly weak tool when it comes to investigating historical events. So anytime you talk science, it would behoove us as young earth creationists to get the skeptics and the evolutionists to back down a little bit and recognize the difference between whether we're studying the way the world works, present tense, or a specific event that happened in the past. Now, we know that events of the past are largely determined and restricted by the laws of physics as we know them. And as young earth creationists, we readily acknowledge that those are the limitations that we operate in. But when you're talking about events, the scientific method in terms of replicating an event is decidedly, like I said, very weak. It's not the thing to do because you cannot replicate a past event. You can replicate cause and effect, present tense, but you cannot replicate a past event. So the creation of the world was a one-time event that will not be replicated again. The great flood of Noah's day was a one-time event that cannot be replicated again. Even if you accepted a Big Bang and a deep time scenario for the formation of the earth and all that, those are all events that cannot be replicated. We also cannot time travel. Another reason why the scientific method is decidedly inferior to determining what happened in the past. The superior means of determining what happened in the past is to have had somebody there at the time to witness it. That is the best way. So if you think of some simple thing like a tree falling in the woods, a person who saw it can tell you what happened. A scientist can come along and kind of determine some things about it. How hard did it fall? You know, he might even be able to help determine perhaps what the cause of it was. But it doesn't take a person of any particular high IQ or intellectual stature to recognize an event. So when you talk about like the flood, for example, Noah knew whether he built a boat. He knew his son's names. He knew how old he was. He knew how many years passed between one particular event and another. You don't need the scientific method for that. That's the inferior way of determining those things. The superior way is to ask the guy who was there. He can tell you and inform you a lot more. So having that in mind, I tend to keep these conversations more scientifically oriented because the scientific method is a valuable tool when you're looking at how the world does work. And like I said, we firmly hold to the idea that the laws of physics in the past were the same then as they are today. So we're not trying to make up our own physics, so to speak. So with that, I'm going to go through some of what I consider the strongest evidences for a young Earth. And I'm going to start kind of with the ones that limit it the least and build forward to the ones that limit it the most. So I'm going to start with lunar recession. What you're seeing on screen right here, I will try and expand that a little bit so you can see it on your own screen. What you're seeing here is the K constant for lunar recession and the integral that's used, this one right here in the middle. This is the integral that's used to determine the recession time and distance. So you've got two different equations here. And so what I did was I took these equations and just mapped them out on a simple spreadsheet so that we could kind of see over time what happens as you wind the clock back from today. So today the moon is about 240,000 miles away from us. And as you wind the clock backwards, it's due to the gravitational pull and the angular momentum, the conservation of angular momentum and the gravitational attraction between the Earth and the moon, plus the tidal bulge. So that's why when you look at this equation, you see that it goes out r to the sixth in this integral or derivative here, and then r to the seventh in the final stage here, because you've got three different masses in consideration, plus the distances between them. So what happens here is I'm a little bit backwards here. Look over here to the right, distance. The distance changes. Well, gravity. I'm talking gravity, not distance. Gravity. It's clocked by distance, but the gravity here. What happens is as the Earth draws closer, the gravitational attraction between the Earth and the moon is proportional to it's determined by the inverse square law that most people are familiar with. If you cut the distance in half between the Earth and the moon, then the gravitational pull is 4 times as strong. So what you're seeing here on the left side of the graph, these are miles from the Earth in thousands of miles from the Earth. And at the bottom, you see the relative strength. So at 240,000, we're at where we are today at 1, relatively speaking. And then as you get closer, 230,000, you're approaching 1.1, 220,000, 1.2. You get down here to 200,000 miles from the Earth, and now you're close to 1.45 times today's gravitational attraction between the Earth and the moon. The relevance there, it has to do with the effects it has on the tide and erosion. If you listen to the professional apologists, what they typically tell you, because they typically design their presentations for a very layman audience, just to give a quick overview. I'm going a little deeper than what the most of the professional apologists do here. So what they will tell you is that at 1.4 billion years, the moon crashes into the Earth because it just gets closer and closer, drawing back in time, which is totally true. But what I'm going to point out is that it is a much bigger problem than that, much sooner than 1.4 billion years. So with that, over here on the left side of the screen, the revolution in days, what you're seeing here, if you start to the right of the graph, 240,000 miles from the Earth, you can see that our lunar cycle is about 30.5 days. But as you get closer and closer to the moon, the actual number of days that it takes the moon to go around the Earth get less and less. So going also back to 200,000 miles from the Earth, you're approaching 25-day cycles, which means you have a much higher erosion rate. And we'll look at the energy and stuff like that as well here in just a second. So with that, what I did here was I kind of plotted it out backwards to show the relative gravitational pull. Now this bar, when you see this is in kilometers, and the miles is over here on the right of the screen. See if I can get them both and view at the same time. Yeah, so close to 240,000 miles. That's today. And then as you get back, what I did was just took 1% reduction in distance and just kind of drove it backwards a ways. And what you see though here is 573 million. This column right here is millions of years before present. So 573 million years ago, the Earth would have, or the moon would have been about 222,000 miles away, and the relative gravitational pull would have been about 15% higher than it is today. So you're talking a little bit before the Cambrian at this point. Now the energy, here's to me the really interesting part of it, because the energy goes up exponentially as the gravitational pull goes up. So try and keep these both in line here. Okay, so 15% increase in gravity, but a 52% increase in energy. That's a huge jump. And what that does is drastically accelerates the erosion rates. And today's erosion rates way back here at 240,000 miles away is already way too fast. If you listen to Michael Ord's presentation on this, he stretches it to 10 million years with today's erosion rates. But if you go back that far in time, 10 million years doesn't even come close to describing the problem with deep time. So we can talk about more about this one a little later on. I'm going to jump over into, I've got some half-life calculations here for both carbon-14 and Earth's magnetic field. Carbon-14 would limit the Earth to about 50,000 years, probably, just because that's roughly the practical limit that carbon-14 can be measured in organic substances per secular science. And so all I'm doing here in this table to the left of the screen here is I'm showing, okay, years before present zero, 100% relative strength. If you go back 5,730 years, because of the half-life of carbon-14 at 5,730 years, you're at 50% of whatever amount you discover today. And you can just keep driving the clock backwards. The further you go, at 34,000 years, you're at 1.6%, whatever today's amount is. And so you can just keep on going. And by the time you get to 120,000, you're at 0.00005% of today's carbon value. So essentially, if you find carbon-14 in anything at all, that it should not be, for example, coal, diamonds, dinosaur soft tissue, that sort of thing. If they are advertising it to be millions of years old, you can look at this chart and say there's absolutely no way in the world it can be that old if you can still measure in, I'll even cut it down to 34,000 or fewer years. If you still have that much measurable carbon-14, that thing, that coal, that diamond, that fossil or that dinosaur soft tissue is not millions of years old. It cannot be. As a matter of fact, I may have it, actually I do right here, mass of the Earth in kilograms. What I've done here is shown that by the time you hit 1 million years, you are gone down to the very last atom, 1.37 E00. That's scientific notation, but you're gone essentially down to the very last atom in 956,000 years, if anything had carbon-14 in it. So there's no way anything that's got carbon-14 in it would still have it today had the Earth actually been that old. And I am about out of time, so I'm going to close real quick on Earth's magnetic field decay, which we can investigate that. That's one of my favorite ones because its half-life is like a third of what carbon-14's is. It's at more like 1,400 years. So as you drive the clock backwards from today, you can see that at creation, rough estimate, 16 times today's value. So that's not really a problem. But if you go back, say 10,000 to 20,000, at 20,000, what you end up with is about literally 20,000 times today's field strength. And the secularists, I believe, they don't have a reversal to supposedly compensate for this before about 180,000 years ago. And if anybody knows a different number than that, they can correct me on that. But I'm pretty sure it's been far over 20,000. So I will yield my time at that and let Doc have it.
Okay, TRock, appreciate it. That's about 13 and a half minutes. And so, as we usually do, the time not utilized in opening statements, we'll toss them into the audience Q&A. Okay, to the audience, I am all caught up with super chats and with questions. And so in just the first opening statement, TRock and Dok, we've got 14 questions. So one per minute of your opening, TRock. That's good. Love to see the audience engaged with these important debates and discussions. So with that, Dok, we're going to now hand it over to you. Let me restart the timer. You also have 15 minutes. And so when you're ready, let me know and you're good to go.
Sounds good. I've run through this a few times. I've tried to time myself. Should be roughly on time. Might go a few seconds over. But hopefully on time. Okay. Dating the Earth. Presented by Dr. Dino. So, who am I and what do I believe? Well, first, hello. My name is Doc Dino. I'm a paleontologist who loves rocks, dinosaurs, and lots of other nerdy stuff. I'm also an insatiably curious person. I base my worldview on the evidence that I've found and the evidence that's been presented to me. I follow a form of methodological naturalism, meaning that unless the supernatural is demonstrated to exist, I have no need to incorporate it into my understanding of natural processes. In addition, by studying natural processes in the present, we can recognize what effects they produce, letting us recognize those effects in records of the past. And what are we debating? Well, we're debating on if the Earth is billions of years old, or if the Earth is 6,000 years old. Oh, sorry, just a second. Now, the former is based on evidence. It is a scientifically tested estimate and assumes that natural processes do and have occurred. It's also scrutinized heavily before it's accepted. The other one is based mostly on the Bible. It's a theological estimate and assumes that the Bible is accurate to real history. Oh, sorry. I'm actually going to exit the presentation here. There we go. Now, in studying the past of the Earth, we do have to make several assumptions. However, these assumptions are reasonable, at least in my estimation. We have no reason to believe that the natural processes today behave differently in the past. So, by studying these natural processes, how old can we estimate the Earth to be? Well, the first piece of evidence I would like to raise comes from a very special place, Lake Suigetsu from Japan. Now, Lake Suigetsu lies along the western Japanese coast and has rather interesting hydrology. Separated from the ocean by tall hills, Lake Suigetsu's only influxes of water are from rain and a small stream connecting it to the nearby Lake Mikata. This means that the majority of the sediment within the lake is from the surrounding hills, which also means that the bottom of the lake provides a great record of what's occurring around it. Now, Lake Suigetsu is a small lake, but it's very deep. At present, it sits at about 30 meters or 100 feet deep, which, combined with its low surface area, means that the bottom few meters are anoxic. They have little to no oxygen for bottom feeders to survive on. This means that the lake experiences little to no bioturbation, which would stir up the bottom sediments. The depth has been more or less consistent for much of the lake's history, confirmed by observations of the lakeshore as well as the varves themselves. Well, wait, varves, what are those? Varves are alternating bands of light and dark sediment deposited at the bottom of some water bodies. Looking at these under the microscope, there's a very consistent pattern. The light bands contain lots of pollen grains, leaves, and other plant matter. This is consistent with deposition during summer months. The dark bands, however, are almost all silt and clay. This is consistent with winter months, when the lake freezes over or otherwise cools and slows, letting fine sediments settle to the bottom. We can further confirm these identifications by examining fresh sediment deposits, because layers exactly like these are being formed every year in Lake Sweigets. So by measuring these varves, how far back can we get? Well, the first attempts to count the varves topped out at about 40,000 years. However, subsequent attempts have topped out at over 100,000. Once again, these are confirmed seasonal varves, and going back to the 4,000-year mark, interestingly enough, reveals no traces of a massive influx of water, which would be very obvious in sediments this fine. And there's something else that helps confirm these ages, but I'll go over that in a bit. For now, though, what if I don't want to stop at 100,000 years? Can we get any older? Well, lucky me, there are lots of other seasonal varve sequences in the rock record. One of the most extensive is the Green River Formation in the western US. Once again, these are seasonal varves, confirmed by examination under a microscope. And they count up to at least 6 million. In other words, about 60 times as old as Lake Sweigets. However, this isn't the limit. We can go back further, because in geology, there's something else we love to measure. That being the decay of radioactive isotopes. For a quick primer, radioactive isotopes are atoms of a specific element that are unstable, and over time, a certain percentage of them within a sample will spontaneously decay into a daughter isotope over a certain period of time. We measure the time it takes for half of the radioactive isotope to decay as a half-life. As an example, a common radioactive isotope, carbon-14, has a half-life of about 5,730 years, meaning that in just shy of 6,000 years, half of the original carbon-14 will have decayed. 6,000 years after that, another half of what remains will be gone, so on and so forth. Radioactive decay happens at a very consistent rate. It has to, going by the laws of physics as we understand them. Going back to Lake Sweigets, we get a consistent reading of carbon-14 going back about 52,000 years. Now, this reading isn't entirely accurate to the layer's actual age, because carbon-14 dating needs to be calibrated, which, since this lake has yearly varves, we can do. And with carbon-14 dating, we try to use organic material that's hard to break down or weather, things like enamel, dentin, wood, or thick bones. This is the case for Lake Sweigets. And keep in mind, carbon-14 isn't the only radioactive isotope we can measure. There are many, many others. As an example, we have potassium-argon dating over here. Now, this method has a small degree of uncertainty due to atmospheric argon concentrations fluctuating throughout history. However, it can be easily calibrated using preserved atmospheric samples, which we do have a lot of. Another method, and arguably one of the most reliable, be uranium series dating. See, uranium as an element is extremely radioactive and decays through a whole chain of other isotopes. This process can go on for millions or even billions of years, depending on which isotope of uranium you start with. U-238 has a half-life of nearly 4.5 billion years, while U-235 has a half-life of about 700 million. Right. Also, we obtain our readings of uranium and its daughter products from very specific minerals, with zircons being the most common, as seen here. A zircon is a mineral that is extremely durable, both physically and chemically, and it is very particular when it comes to what elements and isotopes it allows into its crystal structure. As an example, zircons don't usually accept lead into their structure. They do slip in, but the amount is measured in parts per trillion. compared to uranium, which they allow in, at parts per million. Meaning that, for all intensive purposes, all of the lead found within a zircon is there as the result of radiometric decay. Now, when we do radiometric dating, we don't just go out in the field, pick up a random rock, and shove it through a mass spectrometer. It takes a while to prepare samples, and geochronologists are extremely careful in extraction, preparation, and analysis. I've already given the example of dating Lake Swegat's, the known ages. How about a few more? Right here on screen are two different studies that set out to radiometrically date the eruption of Mount Vesuvius, specifically the eruption that wiped out Pompeii. The first one used argon-argon dating, which is a variation of potassium-argon. It was only off by 7 years. The other used carbon-14 and was only off by 3. Of course, you can get wrong results when radiometrically dating things, specifically when you use the wrong methods to measure minerals. One of the most infamous of these is Steve Austin's dating of the Mount St. Helens eruption. I read his paper, it's awful, and we can go into it more later if TRock is curious. Now then, the current scientific consensus is that the Earth is about 4.5 billion. The current consensus is that the Earth is about 4.5 billion years old. But I'm not arguing for that specific age in this debate. No. I'm not going to put a lid on the age of the Earth, just in case the exact measurement changes because of new data we find in the future. But here are a few rock formations that we've dated to around the 4 billion year mark. On the left are the Jack Hills of Australia, 4.404 billion. Next is the Acosta Gneiss from Canada, 4.03 billion. And lastly, some greenstone from Greenland, about 3.8 billion. Now, none of these are the oldest rocks on Earth, but they are some of the oldest surviving ones. The history of Earth, reconstructed from the ancient mountain ranges, splitting ocean floors, and innumerable fault lines, is a chaotic mess. Frankly, it's a wonder we have rocks this old at all. Now then, I have presented my case for the age of the Earth, but I'd like to take this time to address some arguments I feel TRock might engage in. First up, paleomagnetism. Now, TRock likes to claim that the Earth's magnetic field is decaying, that it has a half-life. That's not how it works. Put simply, the magnetic field is an emergent property of the Earth's core, which has a solid center and a liquid outer coating. This is composed almost entirely of metals, and the core spins within the Earth, generating a magnetic field. This field has an effect on metallic minerals in the Earth's crust. When a lava flow cools, magnetic minerals within align with the magnetic field, providing a record of how intense the field is, as well as its direction. The direction is important because the field seems to flip poles every now and then. Now, if only we had somewhere that was constantly pouring out fresh, metal-rich magma that was preserved for a long, long time. Oh wait, we do. This over here on the left is a section of the seafloor off the coast of the Pacific Northwest. This is a spot where the seafloor is splitting apart. It has the Pacific Plate over here, and it has the Juan de Fuca Plate over here. And it has record of these magnetically charged lines running along the boundary between the plates, going back about 11 million years. Age is confirmed by radiometric dating. And it's far from the oldest one. I couldn't find good pictures online, but we have even older records all throughout the Atlantic and Pacific. These records tell the tale of a constantly flipping magnetic field, waxing and waning in strength. There is no half-life. And again, these times are confirmed by radiometric dating, and further corroborated by metal-rich lava flows all over the Earth. Second thing, TRock likes to appeal to the flood of Noah, in particular saying that the continents moved around in the year-long global flood. Few problems with this, though. First, we know where the continents have been moving away from, at least within the last 200-ish million years. We know this from dating places like the Mid-Atlantic Ridge, which gets progressively younger as we get closer to the center. You can see here, the red spots are younger than the blue spots. Second, if the continents did move to their current position and stop within the span of a year, the Earth would be a glowing ball of plasma. A friend of mine who has degrees in both geology and engineering did the math. The surface temperature of the Earth would be around the same temperature as what we estimate for the center of our sun. Not only this, but nothing in geology supports the idea of a global flood. We have local flood records, or we have local floods in the rock record, and from those, as well as decades of experiments, we know what flood deposits look like. The largest ones we have, like the Lake Missoula flood, aren't even big enough to cover the state of Iowa, the state I'm from. And for anyone curious, this right here is the basic structure of a flood deposit. First, you have a scouring surface, where the water tore away sediments. Up next is a boulder, cobble, or pebble lag, a deposit of heavier stuff, depending on the size of the flood. Next, we have a sandy layer. This is where the next lightest particles are put, and you'll usually see preserved ripple or dune marks. And lastly, a muddy layer, where the lighter particles settle as floodwaters stop or it dries up. Almost all floods follow this pattern. If the entire surface of the world was covered, then we would see this pattern everywhere. But we don't, and there hasn't been enough time for all that sediment to disappear. If there were a global flood, we would see gigantic pile-ups of flood sediments, flat against the Rocky Mountains or the Himalayas. You should see hundreds of Grand Canyons on every continent, both straighter, less wandering channels. They'd be carved deep into the bedrock. Speaking of carving into bedrock, TRock also likes to argue about erosion rates. Something he doesn't realize is that most erosional forces are also depositional, to an extent. The sediment's always picked up and deposited somewhere else where it can be further eroded. And these rates are highly variable. They're not constant. Anyways, that was my opening. A lot of things to get into here, and I hope TRock's ready for a fun discussion. I'm definitely looking forward to it. And I'm happy at least one of my predictions came true. Thank you.
Doc, thank you very much for that comprehensive 15-minute opening statement. Great job to the both of you on your 15-minute opening statements. We have a lot of excellent points and interesting topics to engage for the rest of the debate. Before we move into the next phase of the debate, the 5-minute rebuttals, I do want to remind everybody in the audience that we have 2 open mics coming up on the creation versus evolution topic. And so make sure to be here, even if it's just in the audience or you want to join. So this one will be Friday, and then next week, or roughly within a week, we'll have Paul Price here for a genetic entropy open mic. Okay, TRock, we're now moving into the first 5-minute rebuttal of tonight's debate. And so let me restart the timer. And whenever you're ready, just let me know, and you're good to go.
Donny, I'm sharing my screen again. Okay, one more line of evidence I wanted to talk about tonight, because one of the things that Doc had iterated via email communication before the debate was that he wanted to basically defend a position that the Earth was at least 10,000 years old, I think, something like that, or 12,000, something to that effect. So my comment was, okay, well, you're getting more into kind of a crossover line between historical science and archaeology. History is in written history and archaeology and that sort of thing, and it kind of blurs the lines and makes you have to cross too many subjects to be able to do that. So I wanted to get him to defend something at least, well, what he said, 60,000 years old was what he said. The Earth must be at least 60,000 years old. So anyway, my 2 tightest constraints, my 3 tightest constraints, the 2 that I've named so far, carbon 14, I said approximately 50,000, and then the Earth's magnetic field gets it down to about 10,000. But I've got one more that I want to add to the mix that puts a very tight constraint, less than 60,000 years. And I actually discovered the net effect of this after that conversation with Doc, for your own reference, Doc, 60,000 years. So what I did was I happened to have gone to Missouri to visit some family here a couple months ago. And while I was there, I visited a place called Blue Spring. Missouri, and really, really interesting place. It's freshwater. It's just in the middle of the woods. There's nothing spectacular about it. You have to drive, down some country highways and down a dirt gravel road to get to it, and then you have to walk through the woods a ways to get to it. And it's just kind of in the middle of the woods, not too far off of a riverbank. And it's a freshwater spring. And this spring, it's this one here on my screen, pours out literally 87 million gallons a day of water. 87 million. And it's the 6th largest of Missouri. It's not even the biggest one. So what I did was I went and said, okay, what are the 6 largest springs in Missouri? And it's these 6 right here. And they range from 24 million gallons a day all the way up to 275 million gallons a day that these things put out. And so the only one I actually got to see in person was Blue Spring. I said 6th largest, it's not the 6th largest. It's among the 6 largest. It looks like by these numbers, it's number 2. But anyway, interesting story behind it, because the guys some guys bought this property back in the early 1900s, and they tried to determine how deep it was. So they took an anvil and tied a rope to it and tried to drop it down to gauge the depth. And what happened was they never could get their rope to the bottom of the deal, and so they concluded that they could not find the bottom. Well, fast forward some decades, and some scientists and some other people got involved, and what they figured out was that thing is putting out so much pressure that the guy who tried that on his own land, using his own method, that pressure was so high that the anvil was actually floating off the bottom of the spring. Huge amount of pressure coming up, and it's 320 feet deep, by the way. So what I did was I took all 6 of those and put some numbers together, and I said, okay, how many years would it take for Blue Spring to put out enough volume to basically match the volume of the continental US? And it put it at 65 million years, you would get enough water out of there. Now, I know secularists don't think that spring is that old. I realize that. But I started putting the other springs in Missouri, and I also picked this one up from Utah, Big Mammoth Springs. It's 202 million gallons a day. And when I put them all together, and then I added one more factor in here for the fact that Missouri's got hundreds, if not thousands, of smaller springs that also put out a significant amount. And I just assumed 20% of the net total, or 25% of the 6 listed up here, and added another 147 million gallons a day of various small springs in Missouri, in the state of Missouri. And so I added them all up. And as you do that, what I came up with was in I've got the number over here somewhere. Oh, this number right here at the bottom. Those springs combined put out the entire volume of the continental US above sea level in just 6 million years. Now, I know, again, the secularists probably don't think any one of them is probably that old, and that's fine. So what I did was I took Missouri and its own volume above sea level and calculated those, and it came to 43,175
20
years
seconds
for those springs to put out enough water to match the volume of Missouri above sea level. And if you did that for each state, you would probably come out with some number similar to this. So in my estimation, there's no way those springs can be anywhere near 40,000 years old. I'll concede my time there.
5 minutes goes fast. Wow, I looked over at the timer and thought 30 seconds already. So good job, TRock. We're now going to hand it over to Dok. Dok, you also have 5 minutes. And so let me restart the timer. Whenever you're ready, let me know, and I'll start it on your first word. Just make sure to unmute, Dok.
Sure. Just give me a minute to do something real quick, and then I can go.
Sure. Yeah. If you're going to take a minute, I'll just go over some reminders and announcements. So again, to everybody in the audience, especially those that love a good old open mic, we've been doing these every 10 days. And so make sure to be here Friday. Matt and I will be hosting and also engaging in the second part of this night, the open mic debate part. So if you want to chat some of the more technical topics, ERVs, chromosome 2, and junk DNA, whatever it is, make sure you are here for that. First 2 hours, Kent will be here. First hour, Kent versus Kenrock. And then our next one after this, in terms of the 2-in-1 show, will be with Luca Medugno. And so we got a lot to look forward to in terms of open mics coming at you. If I'm not mistaken, do check the channel. September 7th. So Paul Price, he's done a lot of work on the topic of genetic entropy. He's written extensively over at CMI, on this topic. So he'll be here to give a presentation on genetic entropy, followed by open mic debate. And so if you want to engage Paul Price in impromptu debate on genetic entropy, make sure to be here for this show. I am pumped. An unrelated open mic, this will be on the deity of Jesus Christ. Open debate, is Jesus God? This will be the day after, actually, the Paul Price open mic. So lots of open mic debate on all sorts of topics for people to look forward to. Okay, I see you're good to go now, Doc. So
Yes,
feel
sorry.
free to.
I needed
Oh,
to
no worries.
sketch down a couple notes.
No worries.
Okay, so addressing TRock's opening here. Oh, I don't need to show my presentation.
Okay, you're good to go.
So science is a tool. I mean, I do agree the scientific method is a tool, but a weak one for exploring the past. Not sure I agree with that. A lot of past events we can replicate. Like we can, as an example, like a flood, we can replicate that in a flume chamber, which is where we just unload a lot of water into a confined space or a not so confined space and then study the aftermath. And that aftermath usually mirrors what we see in the real world. So we can use these as a way to, put up different scenarios, like say city planning, to, see what we can do to mitigate flood damage. That's a big thing in civil engineering. So yeah, we can replicate events on smaller scales usually, but we can. You see, personal accounts are really good for learning stuff about the past. To a degree, yes. Personal accounts can be fictionalized, though, or just be entirely fictional, and they only go back so far. You did talk about the lunar recession issue. To my knowledge, it isn't an issue. The moon's been accelerating as it goes away from us because the gravitational pull between the Earth and the moon gets weaker and weaker, while the moon is getting closer to the other bodies in the solar system, which are pulling it harder and harder. But that's been happening for a long time. You say carbon-14 caps the Earth at 50,000 years. So carbon-14 is being constantly generated in the upper atmosphere. Cosmic rays from the sun impact nitrogen-14 and fuse them with stray neutrons in the upper atmosphere. This fusion creates carbon-14, which then eventually over time does decay into nitrogen-14. Yeah, this is continuously generated, and this has been known for a long time. Magnetic field decay, you did go into that a bit. Again, it doesn't have a half-life. I'm sorry, it just doesn't. The Earth's magnetic field is being constantly generated. It does strengthen and it does weaken, but it hasn't only weakened over time. During the open discussion, I'd be happy to find a graph of Earth's magnetic field over the last few 100,000 or million years. I looked real quick on Google, found a few. Going to your rebuttal then, you're saying I was trying to blur lines on, I guess, operational science and historical science, or sorry, archaeology and stuff. No, you said previously that you thought the Earth was about 6,000. I picked 10,000 as just a suggestion number. You suggested I go at least an order of magnitude higher, so I did. At least 60,000. Also, addressing the water coming out of those springs, the number does sound big. Atlanta gets more water, like the city of Atlanta in Georgia, gets more water than that every year in just by rain. The USGS actually has a rainfall calculator, and they have records of it, which I can show real quick. And keep in mind, this water is constantly running off the continent via rivers and streams. So it's not an issue. Like, the streams put out a lot of water, I agree. But Atlanta gets hundreds of times that. Water escapes the Earth. Escapes the US. Other than that, don't really have much else to say for my rebuttal.
All right, Doc, that's basically 5 minutes. And that concludes the opening statements and the rebuttals. Gentlemen, we have a lot of excellent points to discuss over the next roughly 60 minutes. And so to the audience, while TRock and Dok are engaging the points relevant to tonight's topic, again, the topic being the age of the earth. Is the earth young or old? I will be saving your questions. And so please, if you do have a question for TRock or a question for Dok, just make sure you're tagging me either at Donny or at Standing For Truth. That way I won't miss them. And let's do our best to keep them on topic. Again, tonight, the age of the earth. And so why don't we hand it to TRock, since Dok just ended with his 5-minute rebuttal. TRock will allow you to kickstart this discussion with a certain point or maybe a topic you'd like to engage. Go ahead.
Okay, so I think I'll start with the lunar recession deal. What I can get from Dok is he definitely does not do a lot of physics. Made some.
I am more of a rock guy. I will admit to that.
Okay, fair enough. But you made a couple really major physics errors in all of your presentation, your rebuttal, and one of them really stood out in the lunar recession. That is, you said that it's accelerating away from the Earth. It's not. It's decelerating away. It's the exact opposite. It's because the further you get away, the weaker the gravitational field is that's holding it in. That much is true. The gravitational pull from the side is getting weaker, but it's related to the energy lost in the tidal bulge. And so if I share my screen real quick, I'll show you what the recession curve looks like.
So
and
while you're pulling that up, if I may,
wait for Donny to approve it.
I remember you talking about this in your debate with Grayson.
Okay.
And so you know the formula.
Real quick, while you're talking, let me draw attention to this, and then you can go. I just want to draw attention to this graph right here. This is the recession curve. But go ahead.
So, okay. You can have that curve. I don't think that's accurate to the one that most scientists agree on. But so, do you know the basic gravitational equation?
Which gravitational equation? Are we talking universal gravity?
Let me just let's trying to find what it's called, but it's the basic gravitational equation. Basically, mass of object 1 times mass of object 2 times the gravitational constant divided by the distance between the objects squared.
Right. That's how you would determine the gravitational attraction between two bodies.
Yes. So what happens here? I'll share this. What happens when R in this equation gets bigger? Highlighted there.
We've already said that when R gets bigger, those same two masses, assuming they're constant, the gravitational attraction between them gets smaller.
Yes, so the force gets smaller. So if the moon is farther away, then the gravitational pull from the Earth would be smaller, correct?
That is true.
But at the same time,
that's what I pointed out in my presentation.
But at the same time, the moon is getting closer to other solar bodies. So the gravitational strength to those would be getting stronger, correct?
It's no. In a very strict sense, you could say yes, but the problem is if you do use that exact same equation that you referenced to try and calculate a gravitational attraction between the other stars and the moon, you're still going to come out with essentially zero. There's not enough of an effect to do anything. And
how about the sun?
Huh?
How about
It's
the sun?
the same. Where the moon is gravitationally bound to the Earth for a reason, and if it had been there for billions of years, the sun would have pulled it away if it had enough gravity to affect it in that way. But it doesn't.
Not necessarily. As the moon is getting farther from the Earth's pull is getting weaker, but the pull from the sun is getting stronger.
But it's still too small to affect it in that way. It's not.
It is still too small to completely pull it away, but it is getting stronger.
It is literally not accelerating. The moon is literally not accelerating away. I pulled up the equation from the scientific literature on how you calculate the recession rate. The sun is not part of that standard physics.
Just a second.
So if you had, like you guys like to push for all the time, if you actually had a peer-reviewed paper that said the sun is pulling the moon away from the Earth, I would love to see that, but that's not part of the standard physics.
So it isn't the only thing pulling the moon away, but it is one of the things, and it is the most massive body in the solar system.
Again, you certainly do not have a peer-reviewed paper saying such, and the physics are literally developed.
Wait, I don't have a paper saying that the sun is the most massive object in the solar system?
That's not what I said. I said you don't have a peer-reviewed paper saying that the sun is pulling the moon away from the Earth. What I do have is standard physics that basically shows that the tidal bulge is what has the greatest impact on the lunar recession. So you've got the conservation of angular momentum. You've got the moon going around in circles around the Earth. And as that tidal bulge comes up and down, what happens is once it releases, it's kind of like a rebound effect, sort of like if you had a weight on the end of a rubber band and you were spinning it around, that rubber band pulls tension towards you. But if you let any of the tension off, that object can move further away from you. And that's essentially what the tidal bulge is doing. When it releases the tension, it's kind of like letting slack in your string of something that you're twirling around in a circle. It gives the moon a little bit of leeway. What's happened is it's pulled it in. It's exactly the same concept as the figure skater drawing her arms in to spin faster or spreading them out to spin slower. That's what the tidal bulge is doing between the Earth and the moon. The sun and the stars and their gravitational influence have absolutely nothing to do with it because they're so minuscule in trying to incorporate those into the physics. It's just nonsensical.
Something here is nonsensical for sure.
So, again, this equation that I showed, I have a reference for it. You can go look at it. It's very standard stuff. I think this actually came from Science Direct. I'm not sure. Jonathan Sarfati from CMI provided me with the secular reference to it. But in standard physics, this is an anomaly. It's a well-known anomaly among geophysicists. But that's why you're going to have such a hard time finding papers in the open literature for it, because they don't have a good solution. I'll tell you very plainly, Doc, since you might want to know, what some people have proposed for a solution is that they simply argue that the continents were in a different configuration that made the tidal bulge have less of an effect in the past, is what they argue for. The problem there, of course, is it's total special pleading, number one, and number two, you can go back and look at Cambrian maps where they have sea levels. They show sea levels in like the U.S. and other places in the world. And if you go back 500 million years, you see large inland seas in the U.S. So you have so much water covering the continent, covering like the continental U.S. that argument makes no sense even in the secular sense.
So first, how exactly is it special pleading? Second, the configuration of the continents and the ocean was different. Different shapes can have different effects. So just because there is a large inland sea in North America doesn't mean anything. It's about the configuration of all the continents and all the oceans.
So the point of that particular argument, to argue for different continental configurations, is that whenever the moon is passing over land, the land cannot swell up as high. It does actually swell up. The moon's gravitational pull actually lifts solid ground higher than it wants to be, but it can't lift it as high as it can water for all the obvious reasons. So the whole point of that argument is if the moon is primarily passing over land, then the tidal bulge can't affect the energy release the same way, and so the moon can drift away at an even slower rate. Again, it's deceleration. That's the whole point of the argument, and it's special pleading because I already pointed this out. They have water covering huge portions of the continents 500 million years ago, which is where I'm saying the real problem begins with lunar recession and massive erosion rates. If water's covering the continents, you've eradicated your argument that the land isn't lifting as high, so the tidal bulge can't affect the lunar recession the same. You're back to water again.
Sorry, you lost me there. Sorry.
Okay, that's fine. I think I made my point. We can move on. If you care to pick a different topic to pursue, that'd be great.
Sure. About carbon 14.
Real quick, sorry.
Why do you think that...
Real quick, Doc, let me clarify something for you. Earlier, I did not say that you were trying to conflate more modern history. That's not what I said. What I said was the idea of approaching it that way causes kind of a confusion between the different approaches in science. I was not accusing you of anything.
Okay. How about we talk about carbon 14? Why do you think that we should only have a 50,000 year supply?
Sure. So go ahead and start. What stands out about it to you?
Why do you think we only have a 50,000 year supply of carbon 14?
That is not what I said. I never said anything like that.
You did.
I said it limits the age.
You said if the Earth was older than 50,000 years old, we shouldn't have any carbon 14 remaining. You said that in your opening.
No, I said if something were 1 million years old, the deal that I brought up was basically what I did was I converted the mass of the entire Earth to carbon 14 and showed that the half-life was so fast that in less than 1 million years, a mass the size of the Earth of pure carbon 14 is disintegrated down to the last atom. I'm not saying that anything with 50,000, anything allegedly 50,000 years old can have zero carbon. That's not what I said.
I feel like we're saying the same thing. Just you are saying that, okay, I agree with you. If we had an Earth size of carbon 14, almost, if not all of it, would be gone within 1 million years or so. I'll agree with you on that. You seem to be implying with that we shouldn't have any carbon 14 remaining on Earth today. And I'm curious why you think we have a limited supply of carbon 14.
Okay, I did not say that either. What I said was if you have on Earth, in a very generic sense, you can have carbon 14 as often as you want for as many millions of years as you want. That's not what I said. What I was saying was that if you have something like a diamond, diamonds are typically formed deep in the Earth, right? If you have something like a diamond, whenever it's formed, it captures a certain amount of carbon 14 in it from the Earth's core. This is non-biogenic carbon 14, of course. My point was that in that diamond, it cannot receive additional carbon 14 from the atmosphere. It's in the ground. If it could, you would have a problem carbon 14 dating anything, regardless of what it was, because now you're implying that anything in the Earth can receive new carbon-14. That would invalidate the method completely. That's not what I said, though. What I'm saying is when you have things, and if we're not talking diamonds, we can talk about things that are biological in nature, like coal or dinosaur soft tissue. Once they're dead and they're in the ground, they can't receive carbon-14 from the atmosphere anymore.
Okay, so one thing, carbon-14 is very easy to be taken, or very easily absorbed by water. And when it's absorbed by water, it can be mixed into groundwater, and it can contaminate samples. That is a known problem.
Agreed.
That we do have to account for with carbon dating. That said, you are right in that diamonds don't allow water or new carbon into their structures once they're formed. So you think that we have found carbon-14 in natural diamonds?
Oh, absolutely.
We
and
have.
in coal and in dinosaur soft tissue.
Well, coal isn't a problem, and dinosaur soft tissue.
Sorry, why isn't coal a problem?
Because coal as a material is generally very permeable. It's very easy for groundwater to go through coal beds, so it's very easy for them to be contaminated.
Okay, I'm going to take issue with that as an argument. Only, not because I disagree conceptually with it, but only because if that's true for coal, it's also true for a random axe handle that you might find from, the 1300s or something like that. The same would be true for it, and then the method would be completely invalid for that as well.
Not necessarily. There are different analyses we can do to make sure that there hasn't been leaching into or out of an object.
Oh, so
in addition, with the axe handle, we probably wouldn't date the axe handle itself. We would date the strata it's surrounded by, which might have things we can date.
So you can validate that the axe handle did not get contaminated, but you can't validate that the coal didn't get contaminated.
No, I just said the coal is very likely to be contaminated.
Everything is likely to be contaminated if it's in the ground and subject to groundwater transport. Everything is subject to that problem.
Not everything.
It sounds like you're selectively ignoring carbon-14 in coal for irrational reasons.
I'm not. Here, maybe I can help clear things up. Do you have any examples of carbon dating being done on coal that you could bring up?
I don't know that I've got any in my notes. I do have, I believe I've got something here on carbon-14 in dinosaur soft tissue.
Okay. Because, like I said, coal is extremely easy to contaminate with fresh carbon. However, a lot of the readings I've seen for carbon-14 detected in coal beds is topping out at the range of what we would expect to see carbon-14 at, which is 50,000 years. And if you were getting a reading like that, it's pretty likely you're just picking up on residual carbon-14 from previous experiments on the machine.
I'm going to take issue with that. To me, that's special pleading, because what we're actually doing as young Earth creationists, what we're actually doing is two things. Number one, we're consulting the open literature, or at least the scientific literature, meaning that some of it's not necessarily open to the public, but we're consulting the secular scientific literature, and creationists also do their own research. And on topics like this, what they do is they will send their samples to a lab, and it's a professional lab that's also used by secular scientists. So they're the ones doing the work. So if you say this is not a repeatable experiment, for example, it absolutely is. You can go get your own.
I never said that.
Coal sample. Okay, fair enough. I'm just saying that if you say, okay, well, they're creationists, they're doing their own thing. No, they're sending them to professional labs that do this for the secular scientists. The labs tell you what you have. The creationists don't tell you what you have. They simply,
depending on the situation, they can be doing it correctly or they cannot be. Do you have the source for the diamonds?
No, I told you what I had was, and I've got to set a deal here in my settings, but what I had in my notes prepared for this was some information on dinosaur soft tissue carbon-14.
Oh, okay. Well, As I said, for the dinosaur soft tissue, can be contaminated. I would have to see the source on anything less than 50,000 years being dated for dinosaur soft tissue. However, for the diamonds, I do know the ultimate source on that claim, and it is creationists misrepresenting the actual literature.
No, actually, it's not.
It absolutely is.
To me, that's an ad
my
hominem. What you need to do when you read creationist literature is you need to do what we do when we read secular literature. I don't mind at all referring to secular literature, even that endorses evolution and deep time, that I don't at all consent to. What I do when I read their information is I discern the difference between what they can know and what they can't know. So if you eliminate your bias long enough to read some actual science journals from creationists, you can do the same thing with them. You can read their details, see what it is that's possible for them to know and what it's not possible for them to know. And
so, TRock, I did do that. I did read it. I read it with an open mind, hoping they could give me some evidence I didn't previously know. I read the article written by Andrew Snelling in, I think it was 2007. I read the original paper that he was writing on. This is the original source for the carbon-14 and diamonds claim. He was lying about what the paper said. This is not an ad hominem. He was lying.
Well, let me make this recommendation for you real quick. If you're going to say that a creationist was lying in their presentation, you should bring the actual information to demonstrate that instead of just
let me get the links. Because lucky me, not only does, Snelling write it, and where's where is it? My apologies. It appears to have been in 2000. No, that's not the right one. Where is it?
So while you're looking for that, Doc, let me share with you the info that I have real quick on dinosaur soft tissue carbon-14. This is a study done by some folks in a foreign country. They were not U.S. based. What they did was they pulled up some dinosaurs that or some fossils that were I don't remember the exact age of them, but they were, I want to say, kind of late Cretaceous, maybe, yeah, am I saying that right? Late Cretaceous. Anyway, at the 11-minute mark of this video, this is a guy giving a presentation, and he's got a PowerPoint or something like that he's sharing, and so he says low probability of contamination because of matrix on Triceratops had a percent modern carbon of 6.4%. Huge contamination is needed to produce sample percent modern carbon of 5%. It takes a lot of contamination to get up to 5%, but this Triceratops was up to 6.4%. Okay, then he says low probability of contamination because of the same pre-treatment procedure delivers percent modern carbon of less than 1% for many plant fossils. And he says it would have occurred in these plant fossils too, talking about if it were actual contamination. And he says the percent of carbon becomes smaller. This is the key. This is the key, Doc. Whenever you're doing this type of scientific investigation, this is the type of thing you have to look for. And I got to say, I've never seen where secularists even attempt to do these things because it doesn't tell the story they really want to portray. This is what he did. The percent of carbon becomes smaller the further we get away from the fossil upward in the strata. That means that the fossil itself is the source. If it were contamination, it would get larger because you would move toward a source. So if there had been, for example, some ground disturbance, and let's say a rodent died nearby and carbon-14 was being transported from that decaying rodent to the dinosaur, then the rodent would be contaminating the dinosaur, but the percent of carbon-14 would get bigger the closer you got to the rodent and the further you got from the dinosaur fossils. But the reverse is actually true. It gets smaller as you move away from the dinosaur, strongly implying that the dinosaur fossil itself is the source of the carbon-14.
Can you send me a link to that?
I would be glad to. As a matter of fact, let me do this here. I will post it in the private chat here for you.
Okay.
There, I just posted it.
And I have posted the link to the original study I was previously referring to, as well as the article written by Andrew Snelling on the topic.
Okay,
The purpose
I've
of
got
the
that here.
original
I
paper.
appreciate that.
The purpose of the original paper was using Paleozoic diamonds to run through a mass spectrometer to see if the mass spectrometer would show any carbon-14, because there should not be any carbon-14 in diamonds that old. They knew this and confirmed it later by using samples of other things that absolutely did not have any carbon, but they still picked up carbon-14. This was used as a method to detect background carbon-14 in the machine. This is a known issue. This is a paper talking about the issue. Snelling took this paper and used it to say that they found carbon-14 in diamonds.
Okay, let's clarify something real quick here for me, if you would, because I don't have time to read this paper on right here in the middle of the debate. Perhaps you can clarify something. It almost sounds like to me like what you're saying is they took diamonds and were using them as sort of a calibration standard for background radiation or contamination.
Yes, because the diamonds had 0 carbon-14 in them.
Now, when you say had 0, and see, that's exactly the point. If you're assuming they had 0 and then you use them as a standard and then you measure carbon-14 and then say, okay, all the carbon-14 I measured is from the background, how do you know that? That's my point is that's not how you would do a blank sample as a control group. You would literally use a blank like nothing or controlled samples, not something you pulled out of the ground. You would have a controlled standard that you use and use that for your control group. And then from that, you would determine what the background noise, I'll call it, background radiation or contamination is based on that type of standard. You wouldn't do it strictly from a piece of material you pulled out of the ground, because you're begging the question on what the carbon-14 came from.
So, TRock, what you're suggesting has also been done. This was just a proof of concept that it could be done with diamonds too. And other studies that have done this have achieved very similar results. They have done this.
The oldest carbon-14 age equivalents were measured on natural diamonds, which exhibited the high current yields. This is in the abstract. The abstract practically does say that they measured carbon-14 in the diamonds.
That's not what it's saying. That is describing the results that they got from the machine, not what was actually in the diamonds. That is the result of the analysis. And that's how they know that it was wrong, because those proportions are beyond what carbon-14 can be measured to.
No, he literally says natural diamond samples from different sources within rock formations with geological ages greatly in excess of 100 million years yielded, that's the key word here, yielded a range of currents. And then they give the C12 amounts where filamentous graphite typically yields about 150. So he's comparing it to graphite. And apparent, so it yields apparent C14 ages of
Yes.
64.9 thousand years before present. So he
Correct.
literally says in the abstract that the diamonds yielded an apparent age of 64.9
Yes, that
thousand
is what
years
the
in
abstract
C14.
says. The abstract is a condensed version of the entire paper. In the rest of the paper, they go on to explain that this is just background carbon-14.
And I think you've missed a really key point here for basic logic. If that were true, well, number one, you're question begging at that point, because if Andrew Snelling was lying about this, then the abstract is also lying.
No, it's not. Snelling
It
took this
literally
and
says it
misrepresented
yielded
it.
carbon-14 ages. Well, he calls them apparent.
It's saying that they detected carbon-14, not that there was carbon-14 there. Snelling is saying that there was carbon-14 there. No,
So
the machine is detecting residual carbon-14 from previous tests.
No, that's not what the abstract says. The abstract
That's
does not
what the
say
paper says.
He's probably offering it as an explanation. If that were
No,
if that
he's
were
not.
legitimately
I've
the
read both,
explanation,
TRock. He's not.
If that were legitimately the explanation, then there's no point in this paper at all.
It's a confirmation of a known issue. That's why this paper exists. It's testing our methods.
And so another very important point here, when you do it the first time and you say, okay, that wasn't really from the diamond, it was from something else, then you're going to do it again. You're going to go, oh, wait a minute.
I've already told you that has been done.
Listen to this part from the abstract. 6 fragments cut from a single diamond exhibited essentially identical C14 values.
Yes.
And the final statement in this, the oldest C14 age equivalents were measured on natural diamonds, which exhibited the highest current yields. Now, here's my problem. If he says what you're saying that he says in the paper, the scientist or the team of scientists that did this, if they're saying what you're saying that he says, and it means that the carbon-14 actually came from a different source, what that tells me is none of their previous age assignments that they gave to anything were valid. None of them.
And that's not true, because what they're measuring here, sorry. So if you go down to page 4, there's a table telling you the fraction of modern carbon proportions that were registered in the diamonds. The numbers they have here are around 0.0002 or about 0.02% of modern carbon. We don't measure carbon-14 to those extents in anything we use carbon-14 on. We analyze much higher concentrations.
So you basically point blank said that Andrew Snelling was lying. And I'm going to say right now, Andrew Snelling was not lying. He was saying what they found in the diamonds. Now, the difference between Andrew Snelling's opinion and this paper's opinion, Andrew Snelling is telling to me essentially what actually happened. They found carbon-14 in the diamonds. That's what actually happened. Now, if the paper is claiming that the carbon-14 was from some background noise, to me, that's question begging. It's their think-sos of where that came from. They kept putting more samples up there and kept getting the same answer. And then they're going to walk away and say, oh, well, it must all be background because we know that these are millions of years in excess, greatly in excess, quoting verbatim, greatly in excess of 100 million years. We know they can't have any. Therefore, any carbon-14 we do find has to be from somewhere else. To me, that is the epitome of question begging.
And how about when the methods are repeated on non-carbon bearing samples?
Then you would not get the identical and I'm giving you my projection of what you would expect to find if you had a non-carbon-14 sample, something that literally should have 0 in it, because it's non-biological altogether and it's not formed in the earth under the conditions diamonds are. What you should see is a different value than what these diamonds got, period, if there were background contamination. And my number 2 point, very, very important to the methodology, is that if you did discover that there were true background radiation that was conflating your results, one of 2 possibilities emerges from that. Either the method is completely invalid, or you can calibrate it out and adjust for any sample you put under there, and you just mathematically eliminate it, and then the problem is solved. So go grab a different sample that's non-radiogenic, measure it, and I guarantee you will not get the same thing that you got with the diamonds.
TRock,
go ahead.
How many picometers can you measure with a meter stick?
How long is the meter stick? You can't measure any because they're too small.
A meter stick is 1 meter. How many picometers can you measure with a standard meter stick?
None, because they're too small to measure with a standard meter stick.
Does that mean we shouldn't use meter sticks to measure things?
You're kind of equivocating there. No, that doesn't mean
TRock, that's exactly what you just said.
No, it's not.
It is just applied to something that makes it sound more ridiculous.
That's not at all what I said.
What you just said. You just said, because the measurements cannot measure things this small?
That's not what I said.
We can't use them to measure anything.
That's not what I said. That is not what I said. Doc, I'm sorry, but you're going to have to pay a little closer attention to the words. What I said was you cannot measure any picometers with a standard meter stick. I didn't say you can't measure anything with it.
Yes, I agree.
So I'm back to the whole diamond thing. Now, this particular paper is apparently, and you can tell me if I'm wrong here, this is apparently just an open literature secular paper investigating carbon-14 as it relates to diamonds, right? Is that fair?
Carbon-14 as it relates to samples, yes.
So creationists have sent their own diamonds to what I will call secular labs, meaning they're just labs that do the same exact thing that in their lab that they would do regardless of who's paying them to do it. It's what they do. Creationists have sent their own diamonds to secular labs, and they have measured dates ranging, and I'm shooting from memory here, and I apologize, I don't have the link here, but it's easy enough to find. If you go to creation.com, you can find this stuff very easily. Just type in carbon-14 and diamonds. But they basically, and it may have been part of the RATE project, I'm not real clear on that, but I think it was. Either way, they sent diamonds to a secular lab, let the lab analyze them, and came back with ranges from the high 20s to the high 30,000s of years. Well within the acceptable range for carbon-14 dating.
Okay, I do need a source for that.
Yeah, like I said, I don't have it with me immediately, but you can do the intellectually honest thing and just go to creation.com, pull up the deal. We don't have time to go through any scientific papers during the course of this debate, but it's free information. Go to creation.com and study some of their literature and see what you can trace back to open source scientific journals and that sort of thing. But you can also contact the labs they use. You can send an email directly to creation.com and they will tell you which labs they used. And it's probably in the rate book if that's where that study was published at.
Okay. Well, I'm going to let you find the source to back up your claim. In the meantime, while we're in the open discussion, was there anything in my presentation that you'd like to talk more on?
Yeah. Earth's magnetic field. You made another egregious error in physics during your deal about the magnetic field. So, interestingly, you said the Earth's magnetic field does not have a half-life.
Correct. It doesn't.
Absolutely incorrect. All magnetic fields decay via an equation that looks essentially like radiometric decay. So I can cite the exact variables in radiometric decay easy enough, but the electromagnetic decay equation looks almost identical to it. And that is, for radiometric decay, it looks like N sub T equals N sub O times e to the negative KT, where K is a decay constant, T is the time variable. The N sub T at the beginning is the amount you'll have left after a period of time of radiometric decay, and N sub 0 is the original amount, where in secular dating methods for radioactive decay, you're talking about the original sample with 100% parent. Now, all I'm saying, though, is that the decay equation for magnetic fields looks virtually identical to that. And it's what you use for voltage drops on circuits where, let's say you're monitoring your battery level on your phone, for example. It's the same type of equation you would use to follow the decay curve of your the voltage in your battery, and it's also what you'd use to find the decay of a magnetic field. So you can use it on permanent magnets, you can use it on iron magnets, rare earth magnets. It's the same basic concept. It works on all of them. The Earth's core is largely iron and nickel. And we have 200 years worth of data of following exactly this type of decay curve, 200 years. So approximately every 13 years, scientists have gone and measured the strength of the Earth's magnetic field for 200 years straight. Now, this is real-time data. You can measure that. What you cannot measure, per my previous, in my intro, you can't measure the amount of time or the events that caused it to be that way. You can't repeat any of that stuff. So this is the hard science of measuring what the Earth's magnetic field is in real time. So we have 200 years worth of data, and it exactly follows the half-life decay curve as you would expect, because it's somewhere in the 5 to 10% per century. And so it plots very nicely on a exponential graph. 200 years worth of data says exactly the opposite of what you said.
Okay. Donny, could you please share the thing I'm sharing with you right now? Here's about 900,000 or 800,000 years worth of data.
No.
Yes.
No, it's 800,000 alleged years worth of plotting. Nobody traveled back in time 800,000 years ago to get that information.
We don't have to travel back in time to observe it.
So you don't have to verify anything. You can just write an equation and poof, you know what happened.
That isn't what I said. We have things that were present in the past, and we can measure those things to infer things about the past.
Okay, so you've got magnetic dipole field strength. Okay.
Yep. This is the strength of the magnetic field for the Earth going back about 800,000 years.
So let me ask you this real
up and
quick.
down, up and down, up and down.
Let me ask you this real quick. How was that 800,000 years determined?
The 800,000 years is usually determined by radiometric decay within the rocks that are also measured to determine the magnetic field strength.
So here's one of the problems. So I'm assuming that in this, you're probably going to cite reversals.
I'm not going to cite reversals. I'm just showing you what the strength is over time.
Here's the problem, though. There's a little bit of bait and switch in this, because your 800,000 years, you got it from a completely different method, and so you're question begging here. We've got 200 years worth of real
TRock,
data.
I'm not question begging. I'm not question begging. It's not my fault that multiple lines of evidence can come together to give you a conclusion.
Let me rephrase that. This graph is question begging.
How is it question begging?
Because now
the ages were determined by one method and the strength of the magnetic field was determined by another. This graph just plots both of them together.
No, if you've been paying attention to what I've been saying, we have actual measurements live. Nobody measured any of these 100,000, 200, 300, 800,000. Nobody measured any of these directly. What they did was they went and basically assessed the field strength in existing basalts, probably. And then they assigned ages to them and said, see, this is what the strength was back then. Now, and I'm saying you, I don't mean you personally. Now the question begging is, how do you know the 800,000 years is a real number? It didn't come from the magnetic data itself. It came from something else.
Okay.
So that's probably where we
Let's
ought
take
to
this
talk.
one part at a time. You want to talk about the strength first, or you want to talk about the age first? We'll talk about both of them, but let's
The
go one at a
age.
time.
Talk about the age,
Okay.
because you seem to be stuck on the idea that we actually have that from a literal 800,000 years ago, but that's exactly what's in question. So let's talk about the age for a minute and the method that derived that.
Just a second.
So here's one of the points I wanted to bring out, and you can talk about it again because you talked about it in your presentation. Talk about zircons.
Well, first, you asked me a question. Here's a map of the measured ages for oceanic crust. Oceanic crust is almost entirely volcanic due to many eruptions occurring along the mid-Atlantic ridges. Now, when you have volcanic rock cools to form crystals and minerals. Some of these crystals, such as zircons, once they are formed, trap all of the atoms that are within them where they are. Those atoms do not move. Zircons, in particular, allow in uranium, but they do not allow in lead, which is the final decay product of the uranium isotopes we measure.
Okay.
Meaning,
Are you sure?
Yes. Meaning that, well, okay, amendment. Zircons do allow in some lead, but the amount they let in is measured in parts per trillion, whereas the amount of uranium they let in is measured in parts per million. The difference is big enough that whatever minuscule lead content was there doesn't affect the measurement.
Okay. So you're confident then that the formation of zircons gives you a good reason to state that the uranium content is 100% original and it represents the time that the zircon was formed.
If there is no lead detected, then yes, you have a fresh zircon.
Okay. So you would call that, correct me if I'm wrong, you would call that lead. If there was lead there, you would call it contamination, right?
No, I would just call it lead that was there at the time of formation.
Okay. Well, I'm going to tell you very plainly that is what the open literature calls it. It would call it contamination. And so, Donny,
you can call it, I guess.
Huh?
That's one thing you can call it. That's not what I would call it, but you can.
But you do like, Donny, I need to redo that. Did we lose Donny?
Nope.
Sometimes
I'm here. I'm screen sharing from backstage, TRock. If you need to screen share, let me know.
Okay. Make sure I'm sharing the right thing here. Yeah, this is it. Okay. I'm going to show you something real quick, Doc, because the argument that you're making about zircons and how they would exclude lead is actually nothing new to me. I've heard this before, but it wasn't until very recently I discovered this little article. This is Science Direct, Zircon, Volume 1. And anyway, it's a long deal about the geochemistry of zircons and so on and so forth. But what I want to draw your attention to is this right here. This breakdown of the lattice allows the zircon's composition to alter with lead loss and the uptake of incompatible elements such as hydrogen, aluminum, calcium, and iron being common. Incompatible elements. So,
so wait. Go back. Okay. Go to the start of that paragraph, please.
Extreme damage of the zircon lattice during radioactive decay can lead to metamictization, where the zircon gradually becomes amorphous.
So in other words, we can tell when this occurs, and we know not to use those in our analyses.
Yeah, bear with me because I'm getting there. We need to quantify the extent of this process with the peaks of Raman spectrum broadening and moving to lower frequencies. The extent of damage increases. Okay, so X-ray diffraction patterns show an increase in the lattice parameters and structural disorder with increasing radiation dose. Blah, blah, blah. And then he goes on to talk about the incompatible elements. So what I want to do, though, is jump down here to this. They attributed the periodicity of the radioactive decay heat of the creep reservoir, which is enriched in incompatible elements such as potassium, uranium, and thorium. The point here, though, is those, look at this, these measurements show that highly incompatible elements such as aluminum may be present at orders of magnitude higher concentrations on crystallographic defects such as dislocation than within the lattice. So the bottom line is that word contamination, it's a loaded word, and non-radiogenic elements such as aluminum also appear in zircons. So the fact that lead appears in zircons, not at all a mystery. It's happening during formation.
So TRock, no. What this is saying is that due to radiation damage, the crystal structure can be interrupted, letting other contaminants in. But we can tell if the structure has been damaged or not via X-ray diffraction and other methods. So we know not to use heavily damaged samples when measuring zircons.
Yeah, and to that point, Doc, in many cases where natural zircons approach such high concentrations, contamination must be suspected. Now, here's my overriding point on this. They're calling it contamination because they're assuming that when it's not there, then you can tell that it really is as old as the parent isotope suggests it is. But when it is there, they're like, uh-oh, red light, don't use this for dating. That is a built-in evolutionary bias towards the method. In other words, you just pick the correct crystals and the correct spot on the crystal, and you'll get the correct age. But how do you know if you've got the correct age? Well, you're a geologist.
We already went over that. We go for crystals that are not damaged. And also, earlier in that paragraph, some of these values may represent non-equilibrium concentrations because they were observed in highly heterogeneous crystals. So these odd measurements are observed in crystals that formed in really odd situations. They are not the norm, and they would not be used in an analysis.
And you just highlighted the evolutionary bias. You don't know.
Where is evolution in that? I'm sorry. No, this ticks me off. Where's the evolution in that? Please.
Deep time.
Okay, that's not evolution.
Bias.
Thank you. Please stop saying that. Sorry.
Deep time bias is built in. Deep time bias is built into this. You pretty much just said it yourself. Avoid the ones that you think are contaminated. But my point is, you have no idea how either one of them formed. You weren't there when they formed, and they could have both formed at the exact same time. And you literally can't tell the difference. You just pick the ones you're calling heterogeneous as the non-damaged, non-contaminated version that gives you the accurate date. Now, here's the real point I wanted to make.
TRock, no.
How many papers have you written
form.
to date?
We can form them in the lab. We know what concentrations they uptake contaminants readily. We know what leads to them being damaged because we can damage them and see what effects that causes.
Of course you can.
We can test these.
Of course you can damage things in real time and see something. My question is, how many zircons have you actually seen form in nature?
Pick a lava flow. You're going to find some.
That's not what I asked. Did you see the zircons form at that lava flow?
Do I have to see it form on an atomic level to know it formed within the magma?
This is scientific methodology 101, control group. If you don't have a control group that shows how zircons form without contaminants or heterogeneous, as you like to call them, if you don't have a control group to show you that, you cannot tell when you pull them out of the ground which ones formed which way, because they could have both formed at the same time.
TRock, if I have a molten mass of rock and there are no zircons in it, then I let it cool to a rock and there are zircons in it? Did God just drop the zircons in there, or did the zircons form in the lava?
They probably formed, and that's a terrific question, because I've got a question for you as a geologist. What temperature can zircons tolerate?
Don't know it off the top of my head. Let's see.
And so here's part of my point. I don't know it either. I don't know the exact number at all, but I do know from what I've read that zircons survive at very high temperatures. So did they form in the lava when the lava was coming out of the ground? I'm going to suspect probably not. They were probably already in the lava. And so Iron Matt did a good presentation talking about Z-pinch and how that the ratios of parent and daughter isotopes are formed through Z-pinch in the exact same ratios as what we get them out of the ground in. So what I'm saying is I'm back to square one with this methodology and trying to say zircons don't allow contamination in. You've got an evolutionary assumption or a deep time assumption in these papers by calling it contamination without even knowing or seeing how they were formed. And they apparently can form and damage at the same time. That certainly has to be a logical option. They can form and damage simultaneously and include what this paper is calling highly incompatible, non-radiogenic isotopes.
Okay, I looked it up. Zircons melt at approximately 2,700 degrees Celsius.
And what's the temperature of lava coming out of the ground?
Highly variable.
So you still have never seen a zircon form?
That's not what I said, TRock. Okay, Hawaii is about 1,250 degrees Celsius.
Less than half.
Well, that is the melting temperature. That is not necessarily the formation temperature. Okay. Zircons form at about 680 degrees Celsius.
That's
They just
pretty
melt at
low
higher
temp.
temperature. Yeah, meaning that they form pretty low into the cooling of a lava flow.
And so you're basically implying by saying that if you pick the right zircons that are homogeneous, basically what you're implying is that they can't really form undamaged or uncontaminated, that they naturally form undamaged and uncontaminated.
I didn't say that.
That's what the method implies. And with
what method? What method did I bring up?
We're talking about the zircon, using zircons for radiometric dating. That's what that method implies. By calling non-radiogenic isotopes included in damaged samples, by calling them contamination, but holding simultaneously to the idea that dating zircons is a viable dating method, it basically implies that zircons naturally form uncontaminated and heterogeneous and undamaged. That's what that whole process directly implies.
Okay, do you know how crystals form?
Which crystals?
Any crystal. Do you know how any crystals form?
Temperature changes typically.
No.
So ice crystals don't form because the temperature changed?
They form when the temperature changes. That's not how they form.
Well, go ahead. Give us the specifics.
Crystals generally form when either not necessarily. When molecules of similar composition attach to one another via electrostatic bonds or by electron bonds, they bond together and they form in a specific lattice, meaning they form in a continuously repeating pattern. That's how crystals form. When the crystal forms, every now and then, a different atom than is what usually supposed to be in a location can be put in a location. These are usually atoms of about the same size, or atomic charge, or mass, something to that effect. When zircons form, usually they are composed of zirconium, silicon, and oxygen. Sometimes uranium can be substituted for the zirconium in that equation. It just slips in there because it's about the same size and charge.
So
it's included and locked in there, and then it can't move.
So let me ask you this then. So I'm not putting words in your mouth or trying to translate what you think or have said. Do you honestly believe it is the norm in nature, in a dirty mantle, completely open system? Do you honestly believe that when zircons form in nature, that they most typically form undamaged and homogeneous?
I wouldn't say all of the time, but well, there is always going to be variation between crystals. But we find zircon crystals in nature in old and young lava flows or magma or solidified magma chambers.
So let me ask you one more question. So you basically have acknowledged that the zircons can form damaged and quote unquote contaminated, right?
They can form damaged and contaminated, but when they do, we see it.
You see the contamination.
We see that they have been contaminated and or damaged. Yes.
Now let's take that to the next logical step. Can an undamaged, uncontaminated crystal form in the vicinity of one that's forming simultaneously, but yet damaged and contaminated?
Yes.
That's my point. They can form simultaneously. So they're the same age.
Can, but one is damaged and one is not. So we wouldn't use the damaged crystal because it's going to give a wrong answer.
But they formed at the same time.
Yes.
And so how do you know? And then here's the next big step. How do you know it gave the wrong answer?
Probably because it's giving a different age than all of the other zircons in the rock.
So this is where I was going to, though. I was going to ask you a while ago, and you can answer this quick question. Have you published any papers in the literature yet?
I have not. I've read plenty.
Fine. I'm not trying to make any big deal out of that. I'm just curious if you have. But then the question that comes out of this, though, is you obviously, it's a statement and then a question, but you obviously, the primary way you know you got an incorrect answer is through a geological context. If you found the rock on top of, for example, a Cretaceous rock, but you got a 300 million year old age out of it, you know you got the wrong answer because it's on top of the wrong layer. It's a geological context. And you can extend that to more modern dating systems for like carbon-14. You know, with carbon-14, whether you got a quote-unquote wrong answer. If you carbon date, for example, old writings to be 20,000 years old, nobody's going to accept that. They're going to go, wait a minute, these are writings. People didn't exist, or people couldn't write 20,000 years ago like this. And so my point is that the only way you have for a sanity check on any dating method is to go back to some geological context or archaeological context. That's it. So the age of the Earth, the 4.5 billion years, it came from a moon rock. Why a moon rock? Because it has allegedly the correct geological context.
Rocks on the moon have experienced less weathering than rocks on Earth, on average.
Again, more geological context.
The moon doesn't have an atmosphere. It doesn't have any water. The atmosphere and water are the main sources of erosion and alteration on Earth.
So what I see in radiometric dating is an extreme example of cherry picking and circular reasoning. You just pick the crystals that give you the right answer and poof, the method works. But the follow-up, the actual question is, how come there are no modern volcanoes that you can date properly? How come none of them have a 0 timestamp on them?
Okay, that is a good question. So, it takes time for radioactive isotopes to decay into their daughter products. And we know this because we have dated volcanic eruptions of known age that have had time for this decadic process, and we get the correct age. I brought up 2 examples of dating a volcanic eruption in my presentation. And they're not the only ones.
Can you repeat the highlights of that real quick?
Sure. Argon-argon dating was used on the deposits left by Mount Vesuvius after it covered Pompeii. That age was only off by 7 years out of 1,918 at the time. The other was using carbon dating. That one was specifically used on oil that was within a jar from the city of Pompeii. That one was accurate to within 3 years of the eruption.
Okay. So do you believe that validates the method?
It's a proof of concept at the very least.
So here's the problem I've got with that. First of all, you only know it's within 3 or 7 years because of a strong archaeological background on the material. You already know the age. So what happens?
Yes, multiple fields or multiple sources of evidence can come together to give a conclusion.
So, but we know about Vesuvius because of historical writings. And so we can nail it down to the exact year and know whether 3 or 7 years, however far those methods are off, because of the historical writings. So my point then is that you talked about calibration earlier. So
yes,
you literally have to calibrate. So this highlights exactly what I said at the beginning of my presentation. Your historical writings are the eyewitness account of Mount Vesuvius. You are literally calibrating the methods to the eyewitness account, not the other way around. So if you go and repeat that same process, try that method on a different subject, on a different sample that's a different age, again, you're going to go through the same process. You're going to compare it to either historical writings or some kind of strong archaeological context that you can nail down that time, and you're going to calibrate the method to the eyewitness account or to the human activity.
What do you think I mean by calibrate?
You can tell me what you mean by calibrate. I know
what do you think I mean? I want to know. What do you think I mean by calibration?
So I don't know what you mean, but I know what calibration is. Calibration is where you basically take a standard and you would take a series of measurements of something. It doesn't matter whether you're talking mass spectrometry or dimensional metrology. It doesn't matter. You take a standard of a known size or whatever, and then you take a bunch of measurements and you adjust mathematically to make your measurements conform to the standard so that you can plot an extension or an extrapolation or in some cases an interpolation of the data so that you can basically project where your actual measurement should fall. That's why we have a thing called carbon years as opposed to actual years.
Okay, so we correct for error. Is that an accurate short summary of what you just said?
Yeah, I mean, that's good enough for the sake of the conversation. Yeah.
Okay, so we correct for the error in our measurements. With Mount Vesuvius, the correction came from preserved atmospheric samples of the time of the eruption. We took the carbon dating, we took the result, and we notched back the result because of the different atmospheric composition. That's true for the carbon dating. And that method got us almost exactly the right answer.
Yeah, that's why there's an effort out there called IntCal. IntCal, there was a 2013 that I'm aware of, and then there was an IntCal 2020, which is all about this calibration method. So with carbon-14, here's one of your big problems with carbon-14. So again, you're going to calibrate it to a known historical eyewitness report, and then you're going to do that several times over as much span as you can get an accurate eyewitness or archaeological context to it. And so you're going to create this calibration curve, not on a single event, but on a whole series of events spanning as much time as you can get good information on. The problem with carbon-14, of course, is, and that's legitimate, you can do that all you want, but the problem with carbon-14 is the ratios change over time in the atmosphere. They're affected by a number of things. Do you have any idea what affects carbon-14 balance in the atmosphere?
Generally, the amount of radiation coming in.
Is that it?
Which is tied to the magnetic field.
Okay.
It's not the only way, but it is one of the ways.
Anything else that you can think of?
Also depends on what you're measuring. Different organisms will take in different proportions of carbon-14 than others.
That's true. So maybe we can agree that a marine aquatic life form, for example, will not necessarily have the same carbon-14, carbon-12 ratio as a land-based animal, right?
Generally, yes.
Okay, fair enough. I guess what I'm telling you, Doc, is that yes, the amount of radiation that hits the Earth's atmosphere does affect the carbon-14 balance, as well as the magnetic field. The stronger the magnetic field is, the lower carbon-14 production you would have in the atmosphere. Would you agree to that?
So you're saying the stronger the magnetic field, the lower the amount of carbon-14 being generated, right?
Correct. Because it's going to be deflecting radiation from the ionizing radiation from the sun.
Yes.
Okay. We can agree on that part, but I'm going to tell you there are other events, historical events, that drastically alter the carbon balance. Drastically.
There can be. We're seeing a lot of that right now.
One of them is if you happen to denude the planet of green vegetation, of healthy, what we would call living green vegetation. If you denude the planet suddenly, you're going to have a swing in the carbon balance. So desertification, for example, will cause a swing in the carbon balance. Another one is the ice age. If you suddenly bury too much vegetation mass, the plants are no longer able to extract carbon out of the atmosphere, and you're going to affect the carbon balance. Now, if those things happen simultaneously, whenever you have mass volcanic eruptions spewing ash and so forth and gases into the atmosphere, you're really going to throw the carbon ratios out of balance. My point is that when you're calibrating in written history and archaeology, for example, you can create a calibration curve, and it's not linear at all. We know it's not linear. As a matter of fact, it's probably piecewise, because you can also have things like neutron bombs being detonated in the atmosphere that increase carbon-14 production and change the balance. But the point is that if you summarily assume that you can extrapolate outside of the written context that we have for history and archaeology, you're going to be dead wrong, because events happen in the real world that change. And again, it's more than likely a piecewise function, not a simple curvilinear and definitely not linear extrapolation. But the point is, you can't extrapolate at all. So once you get outside of written history, you're kind of shooting in the dark as to whether your calibration is correct or not.
Okay. So to that I say, you didn't pay much attention to my presentation.
Go ahead, repeat the highlight that's relevant here.
Donny, would you mind? Thank you. This is Lake Suigetsu from the west coast of Japan. We have an absolute count of seasonal varves in this lake going back over 100,000 years. Here is how well the carbon-14 readings adhere to the actual age of the varves. Going back 40-something thousand years in this example.
Okay. Are you done, or do you have more to say about that?
That's it for now.
Okay, so that's a really interesting point there, Doc, because you're basically what you're doing is you're plotting carbon 14 ages against alleged VARV ages. Well, here's the problem. Once you got to what does that do there? You only go to, okay, that's depth. Where are your years? Okay, your years are across the top. Once you get to about 5,000 years, you're outside of written history. So do you agree with that?
Depends on what you mean by written. I'll say yes for now.
I mean, literally textual writing. As
You're wrong. I
opposed
think
to,
we have Mesopotamian writings that go back older, but I'll say yes for now.
okay, call it 7,000 years. I don't care. I mean, it's a secular assessment anyway. But my point is, the secularists aren't going to go much beyond 5,000 to 7,000 years for any writings. I know that cave art and stuff like that can be assigned much older ages, but anyway, the point here is that once you get beyond that, you have nothing to positively confirm your calibration. Now you have to seek other methods to calibrate the carbon 14 beyond the 7,000 years, I'll say. And so
TRock?
your VARVs, let me finish real quick.
VARVs for that.
VARVs is one way. You can use VARVs, you can use tree rings, you can use ice cores, and you can even use some isotopic ratios, such as oxygen isotope ratios and some others. I think there's a method for copper and some other stuff like that. But the point is, there's a variety of other methods that you could calibrate against. The problem is they're all shooting in the dark outside of 7,000 years.
Okay. Do you have an explanation for why we have over 100,000 years worth of VARV counts?
So yeah, there's a real good explanation for it, and it's basically that flowing water can deposit something identical to VARVs, and you can't tell the difference. And you talk about looking at them under a microscope. They literally create light and dark banded layers that you can look at under a microscope. They're indistinguishable from what you call annual VARV layers. Now, there's a test that you could do to warrant. There's a couple tests you get, and this is just it. You guys talk about, and I don't want to project this on you, but you are kind of doing the same thing. Everybody does. You talk about the consilience of the evidence and how, we've got the carbon 14 method that tells us this, and we've got the tree ring dating method and the ice core method and the VARV method, and they all converge on the same general conclusion. The problem is they're all rubber bands outside that 7,000 years. But for VARV formation, if you want to check it against other sciences, you've got to check it against erosion rates. You've got to check it against the magnetic field. You've got to check it against, history is a good one. How about seismic activity? So when you posit.
Okay, so sorry, I'm going to keep this focused on the VARVs here. What happens when water moves over sediment?
It depends on the water and the sediment and the velocity and the acidity and the EH. And
what's a general thing that happens physically to the sediment?
Usually some type of erosion or deposition.
Yeah, it usually forms ripples and stuff like that.
Okay.
Do you think? I'll just ask this. Do you think there are ripples within the VARVs of Lake Swigas?
I don't know. There could be or there couldn't be. It's to me, it's
there
irrelevant.
Are none.
Huh?
There are none.
There are no ripples.
There are no ripples.
Okay. So
within
flowing
the
water.
depths of the lake, there are no ripples.
So flowing water.
Meaning that there was never flowing water at that depth.
That's
not only that. If there had been water flowing through the lake, if the lake wasn't stagnant, there would be oxygen brought to the bottom of the lake. And Lake Swigas takes in a lot of organic matter. So there would be a bottom feeder bonanza if the water was flowing. If there was oxygen down there, there is not.
That's not true, Doc. That is just not true.
Moving water absorbs oxygen and transmits it.
You basically got something what appears to me to be something like a false dichotomy here. You've either got low volume flowing water in like what you would typically think of a typical spring or summer rain event, or you have a very still, calm environment where everything's settling vertically and nothing is disturbed. That's a false dichotomy.
Right. There is a gradient. However, all of the samples from the bottom of Lake Swigetz indicate that it is towards one side of that gradient. That side is no flowing water.
Now you've got a false trichotomy. Now
How?
you've offered one
How?
extreme.
I'm saying this is towards one side of a gradient of no movement to always tons of movement. This is on the no movement side of that gradient.
I know.
There is no third point to compare to here.
Yes, there is. So your false trichotomy now is that you have a piecewise process that accumulates over time via very slow deposition, vertical deposition. You've got a piecewise that accumulates over some period of time, but layer by layer, a little bit at a time. There's an option that falls completely outside it, and you've given the gradient in between those. But there's something that falls completely outside of the gradient, and that is mass flow.
What is mass flow?
Mass flow is exactly where you get those exact same signatures. When you have mass flow, you can have all of the layers parallel. You can have alternating bands, light and dark. You can have the anoxic conditions. You can have 100% of it, but it's all happens simultaneously in a single movement. And we have flume experiments that demonstrate this, and wait, real live natural
by mass
events
movement,
that
are you talking about things like underwater landslides?
No. I'm talking about what they call like the Little Grand Canyon, the 40th scale deal. You can also see them at Spirit Lake and some of the regions around Mount St. Helens after its eruption. There's another canyon somewhere in, I want to say it's in the eastern or northeastern U.S. That was basically a rapid erosion / deposition event that did the exact same thing. It's a single event, thousands upon thousands of layers. They're parallel. It does the exact same thing. There's more than one mechanism besides slow and gradual vertical deposition. That's and the reason I'm bringing that up is because
can you show me one of the things you're talking about? Because can you show, please?
I lost my train of thought. My apologies.
Just can you show me one of the things you're talking about? You say form in the same context as varves, please.
If you give me some time, I don't think I'm going to sit here and hold up the conversation, the debate, for the sake of going and grabbing you some examples.
I'll just say, if what you're saying was correct, then we would not have seasonal differences between the light and dark layers like we do. If they formed at the same time, they would have roughly the same composition, because that's how deposition works.
So
they would not be segregated like they are, and they are segregated going back again over 100,000 years.
No, and that's just
counted them.
That's just it. You're assigning annual layers. You're assigning an annual time frame for them. And I'm telling you very plainly, you can go look at some VARV experiments. John Mackay does them. Some other creationists do them, because the evolutionists just don't tend to like to do this sort of thing. But there are some secular groups that have done this as well. But you can go look at actual flume experiments and see how banding layers, light and dark, happen. Kent Hovind has an example of it, but you can get these exact same light and dark banding layers. And like I said, there are natural examples. You may be familiar with Tom Salk. I don't know if you know about that or not, but it's a place in Missouri. There was a man-made dam that got breached and overflowed and kind of flooded a town down below it. But anyway, every time you see those big dam breaches like that, you have a chance to see some broader scale erosion deposition. And it always makes a good close approximation to what we see in the geological record. So one of my points there, though, was that you talked earlier about flooding, and you had a diagram up there, PowerPoint with a little pictograph thing showing, and you said this is what happens when something floods. We know what floods look like, and it was again another major false dichotomy, because or an equivocation at the very least, because what you did not do was show the mechanism and the scale of a global flood. That's a very different thing than having a local riverbank flood.
Okay. TRock, I cannot show you a global flood because there has never been a global flood.
You can't show it. If there were a global flood, and there was, you couldn't show it anyway. It's not possible.
We could, because we know what floods look like. Regardless
do you know what a global flood looks like?
TRock. Regardless of the scale, this show my presentation again. It is the basic outline of what a flood looks like. This is what all flood deposits look like.
That is one of the
Donny
most
went to get some water, so I can't show you.
That is one of the most unscientific things you've said all night, Doc. That is not what all floods look like at all.
Forms a specific section of deposit? No. Here is what happens when you have a flood. You have water overflowing a bank or spreading out into a new area. When the water spreads out, it is going to erode. It erodes, creating a scoured surface. If the flood is big or strong enough, you might have snapped trees or moved boulders, which you can see because they leave ruts behind them. We can see stuff like that. Then the heaviest stuff gets deposited first. This can be pebbles, this can be cobbles, or this can be boulders, depending on the size of the flood you have. Next, you're going to get lighter particles. The thing after pebbles is sand, going from coarse to fine. And the thing about sand is sand loves to roll over itself. So the sand, while it's being carried by the flood, creates ripples or dunes, depending on how big the flood is. It's going to leave those very specific features. It's called cross-stratification. Those are what the orange lines here represent. Lastly, after the flood has either stalled or starts to evaporate away, it leaves clay behind, the lighter stuff. We do not see this all over the world. We don't. We see massive bands of, honestly, in comparison, random sediments piled on top of each other in no discernible order that would be caused by a singular event. We see uplifts, we see movement, we see metamorphism, and then we see erosion cutting all that off and new stuff deposited right on top. We do not see a flood in the rocks. We do not see a global flood. We see local floods. I've seen them myself.
Okay. Are you done?
There's no flood.
Are you done?
Yeah.
Okay. Now I'm fixing to completely rebut everything you just said. There is a difference in scale. You said that regardless of scale, but there's absolutely a difference in scale. Do you know the difference between turbulent and laminar flow?
Yes.
Okay, so I'm not trying to quiz you or anything. I just make sure you have a good mental reference frame here for the sake of the audience, because in turbulent flow, now turbulent can mean two different things in a general sense. Turbulent can mean fast moving, or it can mean a variety of vector directions that the fluid is moving in. It can be one or the other, or some combination of both. That's turbulent flow. What you've done is you've equivocated on the small scale of a local flooding event like a riverbank, and you've equivocated that with very large scales. Now, ignoring global, but very large scales are different for one real important reason. That is that the height of the obstacles, the solid objects interrupting the fluid flow. So whether you're talking about trees or cars or pebbles of sand or whatever, if the water is, for example, 5 feet deep and your obstacles that are interrupting it are 2 feet tall, you've got 40% of the water depth is interrupted by solid bodies. That creates a high degree of turbulent flow. But what if the water is 300 meters deep and the object is only 1 meter tall? Now you've got 100-to-1 ratio, which means the vast majority of that fluid flow is going to be laminar, probably, as long as it's not interrupted at boundaries. So the differences that you get in deposition are drastically different by scale. So I think you need to completely revisit your whole presentation there.
No, okay, TRock, what you need to understand is we can model every single situation and every single variation of a flood. And like I said, we can model large events on a small scale. We do this in the modern day.
Okay, so let me ask you something.
Let me finish. We do this consistently, especially in, say, civil architecture or stuff like that, or civil engineering. We do this and we get it pretty dang accurate to the actual thing, because the difference between a small thing and a big thing, sometimes it's just the scale. They will behave in the same way to the same interferences, just on a different scale.
I literally just explained why that's not true, but let me ask you this, and you can.
Well, I'm sorry, you don't know anything about modeling, apparently.
No, let me ask you a very important modeling question, Doc. You guys are really big on I can't trust the creation literature. Let me ask you about the secular literature. Is there a peer-reviewed paper that has modeled a global flood?
Give me a few minutes. I can probably find one.
Gentlemen, I'm going to jump in real quick because we are about 2.5 hours into this excellent debate. It's been really comprehensive. Lots of great feedback from the audience. I like these kinds of thorough debates where we can really go back and forth for a while on these points in a free-flowing manner, a free-flowing discussion. I feel like we've kind of shifted now to a global flood debate, which means maybe this is a good place for us to wrap it up and move on into closing statements, if that works for you, gentlemen. And that way we'll have plenty of time for audience Q&A as we're going to try and wrap this debate up at the 3-hour mark. So let's say 10 minutes worth of closing statements, and then we'll do about 30 minutes of audience questions. So with that, TRock, you did kick us off with your opening statement first. And so let's give you the first 5-minute closing statement. Whenever you're ready, TRock, go ahead.
Okay, I'm going to share my screen real quick.
Sure.
And I may need to stop and reshare here because I think I'm shared to a specific. I need to share to a monitor, not a okay. Okay, go ahead.
You're good to go.
Okay. I want to highlight again some of the things that we've talked about, particularly where it concerns Earth's magnetic field. So all I'm showing here is what a typical exponential decay curve looks like. And so we heard Doc basically say that the Earth's magnetic field does not have a half-life. In other words, it doesn't really decay per standard electromagnetic theory when we know, in fact, it does. We have 200 years worth of data that plot it looking exactly like this type of curve. It's an exponential decay. 200 years worth of real-time data. That's how electromagnetic theory works. It's easily predictable in any number of physical environments. One of the problems with the rapid decay of Earth's magnetic field is heat. Doc not really understanding the physics behind any of this. Heat is what destroys magnetic field very quickly, and the reason is because at the molecular level you start de-aligning the molecules. If they have a north-south, if they're a dipole magnet, for example, they'll have a north and a south, and when the norths are both pointing the same direction, so you're north to south and then north to south right behind it, so that they're aligned properly, you get a stronger field, and what heat does is de-aligns those and makes the field weaker. So the longer you have heat applied to a magnet, it does not matter whether it's some kind of iron nickel alloy, doesn't matter if it's a rare earth element, does not matter what it is. The longer you apply heat to it, the more you're de-aligning at the molecular level and weakening the magnetic field. The heat has always been there. It's never not been there. So I wanted to kind of recap that. He basically tried to talk about lunar recession in terms of accelerating away from the earth, when in fact it's the exact opposite. It's a deceleration away. He doesn't really understand what's happening there. It's related to the energy in the tidal bulge releasing, and again, it's an exponential curve. The expectation is, again, one of the big points I wanted to make there was that go back and look at some of the alleged ancient maps in the secular time frame and see how much water is present. The more water you have present, the higher the tidal bulge can be at any given location. So deep water means taller tidal bulge, and shallower water or land means much lower tidal bulge. But the ancient maps show huge amounts of water all over the continents where they shouldn't be. So the question is, how long ago did that happen? But it couldn't have been 4.5 billion years ago. Couldn't have been 500 million years ago, because the pull of the tides alone develop so much energy with the moon at that close to the Earth. Even just 10% difference between today, between today's value and that, 10% yields in excess of 20% gravitational increase, which yields in excess of 50% energy increase, which means your tides are now ripping your continents apart. So nothing about the secular timeline in terms of an ancient Earth makes any sense in that vein. We talked about carbon-14. Carbon-14 decays extremely rapid. Any experiments that you do, any measurements that you take of carbon-14, the real key example I brought up was the one from this study that was done by a foreign group. I believe they may have been Korean, but either way, they measured carbon-14 in dinosaur soft tissue, and they basically empirically showed that the dinosaur soft tissue itself was the source, because, and I'll show that reference here real quick. Because it gets weaker moving away from the fossil site. So it is this reference right here, and I believe I posted that in the private chat, so you can go check out that video. The quotes that I put above there are also very illuminating as far as carbon-14. I didn't go over all of this, but they conclusively showed that the dinosaur soft tissue itself is the source. It's not contamination. It's way above contamination. It's way above heavy contamination levels. It's not exposed to atmospheric conditions where it can receive more carbon-14. The only way it could get it is through groundwater, or if it is the original carbon-14. That's it. It's very conclusive. That limits the age of the Earth to well below 50,000 years in this case. So with that, I'll yield my time. Hopefully we'll have a good Q&A and a little bit of chance afterward to do an open mic kind of discussion more about these topics.
Okay, here we go. As always, the debate typically continues into the audience Q&A. So I'm sure we'll be even more comprehensive in the audience Q&A. So Doc, you now have your 5-minute closing statement. And so when you're ready, just let me know and I'll start your timer.
Sure. I'm going to keep it brief. And I'll say this as politely as I can, but I'm sorry, TRock, you do not understand a lot of science. You have severe misconceptions about physics, severe you don't seem to understand math very well, and either you cherry pick like crazy, or your reading comprehension is painful. I am disappointed in this debate, and after all this, I'm not sure I would trust you to find north on a compass rose. I am done.
Doc just muted himself.
Doc, I think you might have accidentally mute yourself.
I said I was done.
Oh, that's it. Just
You muted yourself before you said the word done.
Are you sure you only want to
Pretty
use 40
sure I
seconds
didn't,
of your
but
closing?
whatever. Yeah,
Okay.
I'm sure. Let's get to the questions. I need to take an Advil.
Okay, no worries. Okay, gentlemen. Comprehensive debate, 2.5 hours as usual with these debates has flown by. Quick reminder to the audience, we will be back here tomorrow night. We've consistently hosted for the summer between 4 to 5 events a week. Last week, we actually had about 3 main events in the same week. And so tomorrow night concludes our summer of debates. And so we'll be enjoying a debate here between Carlos Xavier and Pastor Kevin Tremblay on the important question, is the Holy Spirit the third person of the Trinity? And then September will be no different. September is packed with, again, about 4 to 5 events a week. We'll be starting the month off September 1st with another one of our 2-in-1 open mic showdown. So Ken Rock versus Kent for the first hour, and then Kent and Ken Rock for about an hour open mic, and then we're just going to open it up for everybody, just a free-for-all for another 2 or 3 hours. For those who love good old open mics, we're going to have Paul Price here on September 7th, I believe it is, for a genetic entropy open mic showdown. So we're expecting all of the critics and skeptics to join us for what is, I'm sure, to be an open mic to remember. And so with that, gentlemen, break time's over. Hope you're all refreshed and ready to go for roughly 30 minutes worth of audience questions. And so we're just going to start right at the beginning, gentlemen. And so the first question that came in is from Jay Delgado. Jay Delgado sent in several super chats in order to make sure we get this question in. So 1, 2, 3. Jay, I appreciate the support. I appreciate the super chat and the question. It's not 100% on topic, but I would like to honor Jay's gifts here. So it's up to you, Doc, if you'd like to respond, but we'll go through it here and we'll get your thoughts, TRock and Dok. So Jay says,
yeah.
Okay, so Jay says,
sorry,
Donny, ask them to give a chronological evolutionary order for man's 10 vital organs that passes the laugh test, 1 through 10, skin, heart, so on and so forth. Here's your list here. So, gentlemen, do you have any thoughts on that overall? Did you want to speak to that, Doc?
Yeah, sure. This isn't an exact order, but probably go. Well, actually, it depends on how you define lungs, because if you accept a permeable cell membrane, that might be first. But that would also count as skin. So now I'll go with like the vertebrate concept of lungs. Probably be skin, heart, brain, stomach, intestines, well, sort of. Then the others in assorted order, but it really depends on what you define things as.
Okay, Doc, thank you. TRock, any thoughts on that? I think you might be on mute, TRock.
Sorry about that. Okay. Yeah. Great question, Jay. What it highlights to me is the nature of evolutionary thinking, trying to piecewise everything together. Piecewise does not work. I talked about that a little bit in the idea of calibration. Events like carbon-14 I would think of them definitely having the potential of being a piecewise function. What that means is you have a short mathematical equation that can define a short period, but then you have to have a completely different one to define the next period and so forth. The relevance here is that you're trying to piecewise a human body together over millions of years and across a whole bunch of generations. The problem with that, of course, is that these are highly integrated systems that need to come together simultaneously, just like if you drive the same concept back to the cellular level. What's his name? World-renowned expert on biochemistry. I can't think of his name at the top of my head, but he did a presentation here recently about how these chemical methods don't come together like that. And the reason they don't from the outset is that biochemistry is comprised of a high percentage of weak hydrogen bonds, which are easily broken apart. They're subject to all kinds of catastrophes and damage through natural environmental conditions. That's why biomaterials break down. You know, you find a dead animal on the road, it disintegrates rather quickly. It's because of how many weak hydrogen bonds are. The point is that you can't piecewise things together like that. You can't do it with mutations over time either, which is kind of what this more directly alludes to, because of the exact same reason. Random chemistry in the world dictates that you're going to interrupt the flow very easily. It's going to be it's like background noise that just kind of scrambles the path that supposedly could lead to, but nothing in life is ever actually done that way. It's done by creating an entire integrated functioning system all at once. It's the only thing that we as human beings have ever seen happen. It's what we do intuitively when we design things. We make an integrated system fully functional out the gate. We don't piece it together over long periods of time.
Thank you, TRock Dok. To be fair, the question was more so directed at you. So for this one, if you'd like the last word, go ahead.
Sure. Simply saying to that, okay, not all of these modern features appeared at once, nor did all these modern features appear one at a time. Features gradually develop in different ways for the needs of different organisms. Not every organism has a skin. Not every organism has a heart, or intestines, or a pancreas, or a liver, or a brain, or lungs, or a stomach, or kidneys. We have organisms that exist without any, or even all of these, and they still live. So, and there are intermediates for all of them. That's my end.
Okay, appreciate it, Doc. And again, Jay Delgado, appreciate the support and the super chats. Okay, next question comes in from Based Theory. So Grayson and TRock, they've duked it out in the past. And so he's coming at you, TRock. He's bringing the heat here. He's got a question, and the question is, if a magnetic field is continuously being created by a dynamo process, then it would not follow a decay curve since it's continuously being produced each second. No question mark.
Okay. What there is a hypothesis that has been put out there in the open literature about a dynamo process, but that does not describe the Earth. And it's very obvious it doesn't describe the Earth at all. Dynamo, basically, another way of saying it is what they call differential rotating core. But the dynamo can be different than that, to be fair, because the dynamo can be kind of like what they would call tidal pumping. But the problem is that that's not the nature of our magnetic field at all. What it is our magnetic field is the result of an electric current passing through the Earth, and it collapses and creates the magnetic field, and the magnetic field collapses and reinduces the electrical current, and it's just a cycle up and down. It's the exact same type of cycle you would measure and detect in an electronic circuit. There's no difference. Tidal pumping has nothing whatsoever to do with it. And he says, then would it not follow a decay curve? So the problem there, of course, is that the curve is exactly what's been measured with 200 years of real-time data. It is the curve. It's the same curve you measure in an electronic circuit for, like I said, voltage drop. Hook a light bulb up to a battery and watch the voltage of the battery decline over time. It will fit the exact same type of curve. So the more common rescue device here to say it's not curvilinear is that reversals. What's the problem with reversals? Reversals actually accelerate the demise of the magnetic field because they consume energy. When they consume energy, they release a certain amount of heat, and so the heat again destroys magnetic fields. So base theory, Grayson has argued that the process doesn't follow. He used the term linear. That's incorrect mathematically. It'd be curvilinear, but he basically was arguing that it can't follow a curvilinear form because of reversals scramble it. And my response would be, if you actually watch a reversal decay, you start out curvilinear until you get a reversal, then you get these spikes up and down, and then once the reversal stops, it settles back down closer to where it started at the beginning of the reversal, but it drops faster. And now you're back onto a normal decay curve until you get another reversal. But as soon as you do, all you do is get spikes temporarily. And then once the reversals kind of settle down, you go right back to the curvilinear decay, because that's what magnets do. Ours has a 1,400-year half-life, or somewhere in the vicinity of 5 to 10% per century. They plot the exact same way if you do the math correctly. But the reason it's so fast is because of how hot the core of the Earth is. And so I asked the question early in my presentation, how long ago was the alleged last reversal? And if somebody has an answer for that, I'd love to hear. But it was my impression that it was some 180,000 years ago. But that's way too long to not have a reversal. And because as long as that's not happening, you should be following the exact same curve that we have plotted with real-time data for 200 years.
Okay, TRock, appreciate it. Doc, the floor is yours if you'd like to respond.
I don't know anything about physics, but what I've heard about it, I don't think TRock has a good grasp on the dynamo theory behind the Earth, but I would like to ask that we keep the responses a little shorter. I'm sure there are plenty of questions, and I'm only around for a limited time.
Doc, appreciate it. Yeah, what we'll do, gentlemen, if you can, we'll let's say keep them to 2 minutes max, and then that way we'll be able to get through as many as possible. So with that, let's move on to the next question. And I do sense a possible round 2 or 3, possibly. I can't remember. How many times did you and Grayson debate, TRock? Once, right? One formal debate?
Yeah, I think that's correct. To twice if you count the time me and Professor McQueen engaged.
Oh, right. Yes. The fossil record event. We went, 4 or 5 hours? That was an excellent event. Okay, so with that, next question, echoing erudite. Question for Doc. Why is it so easy for C14 contamination to happen to materials like dinosaur bones and diamonds? Isn't there a way to tell between when C14 formed or contaminated them?
Sorry. Okay, so for a lot of dinosaur bones, the bones themselves are usually permineralized versions of the original bone, depending on what they have been replaced with. If they have been replaced, sometimes it's easy for water to pass through them. And as I said earlier, water can carry carbon, specifically carbon-14, and leave it in deposits within the bone. It can also do that with original bone as well. For diamonds, though, any contamination you'll have with a diamond is going to be superficial. Well, at least for older diamonds, if you make them in a lab, you can't have carbon-14 because you just made them. If they're older than 50,000 years, though, nada.
Thank you very much, Doc. TRock, floor is yours.
It's an excellent question, and we covered this pretty well, I think, during the discussion. But it does highlight the problem. Why is contamination an issue for dinosaurs and dinosaur bones and diamonds, but not for everything else? They're all subject to the exact same problems. As a matter of fact, a lot of modern things that you carbon-14 date are right on the surface, exposed to real-time weather, and we still carbon-14 14 datum. Dinosaur bones, now, one of the things that happens there is during the permineralization process, you can get effectively a shell on the outer part of the bone while the inside remains untouched and unpermineralized. And the reason is because that contaminating groundwater is not penetrating the outer shell that is now literally solid rock or hardened minerals. So it's not penetrating into the bone anymore, into the middle of that sample. That's what Mary Schweitzer discovered, because she had to break a T-Rex bone open. It was, I believe it was lightly permineralized on the outside, but when she broke it open, that's where she discovered all this soft, stretchy tissue. So yeah, if contamination were an issue for dinosaur bones and diamonds, it would be a problem for everything, and the method wouldn't work, or it could easily be calibrated out and you would still find discernible carbon-14 in dinosaur soft tissue and in diamonds.
Thank you, TRock. Doc, question was for you. Get the last word. Go ahead.
Sure. First of all, contamination is a known issue. That's why we do our best to analyze samples that haven't been contaminated. And yeah, carbon-14 can latch onto dinosaur bones or be carried through them, or dinosaur fossils, or be carried through them. It's a known issue. We take into account these issues.
Okay, thank you, Doc. Next question comes in from Jackson Rowe. Jackson Rowe's got a question for TRock. Why are glass sponges in the South China Sea up to 1,000 years old?
Okay, that question presupposes that they're actually 11,000 years old. I think it would be a little better to phrase the question, why are glass sponges in South China Sea dated up to 11,000 years old? Well, the information I could find on that was carbon-14 dating. And so this goes back to what I was saying before. The calibration curve for carbon-14 is so erratic over time. There are a number of things that can affect how that would be calibrated. Once in this 11,000 year date is well outside of written history. So you're basically shooting in the dark, like what I said before. 11,000 years kind of indicates that you've got a lower C14 to C12 ratio, where more of the C14 has decayed away. But again, a number of global geophysical processes can affect that. So there's no way to calibrate for it correctly.
Appreciate it, TRock. Doc, floor is yours.
Just curious, TRock, if the ages we had for these sponges were, say, 4,000 years old, would you still have the same answer?
Absolutely. This is one of my highlights that I've made in past debates, is that you cannot date anything. There is no objective dating method for anything. There's no chemical test. You can't date a pencil. I could bring you a rock. I could pick a random rock off the ground. You have no test that can tell me what the age of it is. The first thing you would have to ask is, where did you get the rock, so I could give you some geological context. If you dated these things at 4,000 years, I'd just be like, okay, whatever. You probably don't have any idea whether that's accurate or not.
All right. Appreciate it, gentlemen. Next question comes in from Stephen Tibbetts, and he's got a question for you, Doc. If C14 levels are still increasing due to not reaching equilibrium yet, how can you be sure old dates aren't just lower amounts of C14 at that time?
Because carbon-14 decays into nitrogen-14 at a known set rate. It does it on its own over time. I don't know. Actually, I think the amount currently in the atmosphere is decreasing at the moment, though that's mostly due to burning of fossil fuels, which are very depleted in carbon-14.
Thank you, Doc. TRock, floor is yours.
I think the implication of the question there, though, is how do you know what the initial conditions were to know where on the decay curve you're supposed to be? That's the implication of the question. And per my comments that I made earlier during the discussion, a number of geophysical processes. If you have a lot of, and the reason I brought this up is because we do adhere to a young Earth with a global flood. And so we get a lot of volcanism in a short amount of time with a lot of carbon in the air. And so this question kind of alludes to the idea that, okay, ignore all that. We'll just do a smooth curvilinear extrapolation over time to a point in the past where carbon production was just lower and it's steadily building over time. You could hypothetically calibrate for that if that's all you had to deal with, but you don't. You also have the fact that you get all this volcanism happening simultaneously, plus denudation of the vegetation on the planet, and you completely disrupt the balance, so you have no way to compensate for that mathematically.
Okay, thank you, TRock. Doc, question for you, Doc. You get the last word.
All I'm going to say is we can calibrate for past atmospheric levels using known counts. And I'll leave it at that, because can I request we shorten to 1 minute? Because at this point, we're mostly just repeating things we already said in the debate.
Yes, and regardless how long we go per question, we got about 9 minutes left anyways till we shut it down. So we'll get through as many questions as we can. And so maybe for the next 9 minutes, we'll go power rounds, I should say. So, okay. Let's see. Next question here comes in from George Bond. Question for Doc. The mineral abernathite, hopefully I didn't butcher that, contains 45.77% uranium, but no appreciable quantity of lead. If the Earth were 4.6 billion years old, then it should contain slightly more lead than uranium. Go ahead.
First, I'm going to say I've never heard of that mineral before. I'm looking it up right now. It does indeed usually contain plenty of uranium. Abernathite. Yeah, I don't know. I've never heard of it before. I don't have anything to say on that.
No worries. Appreciate it. TRock, any thoughts?
Yeah, this is, I don't want to take up too much time. It's hard to give good answers to things like this in a really short time. But one of the things I looked at that I thought might come up during this discussion was the Oklo reactor, because that's an evolutionist, a favorite go-to for some evolutionists for proof of an ancient Earth. But one of the things that I discovered in that is that the byproducts of the fission reaction, the scientists went looking for them to find the byproducts that should exist, and they did find them. Guess where they found them? Like 2 meters from the reactor. In other words, 1.8 billion years of weathering, and they assign the actual duration of the fission reaction time itself to anywhere between 100 and 500,000 years. But anyway, over 1 billion years worth of weathering, and the byproducts are 2 meters away. And so you couldn't even, and that makes no sense whatsoever. So you couldn't even appeal to weathering here for the explanation in this case.
Appreciate it, TRock. Doc, over to you.
Okay, looked it up a bit more. As far as I can tell, abernathite is only found in some very, very select areas in the world, and it's usually found as an incrustation on exposed sandstone formations. That might indicate that it's a very young mineral that just hasn't had time to radiometrically decay. Could be wrong on that, though. I am literally just looking this up for the first time.
All right. Thank you, Doc and Rock, for your responses. So next question comes in from Creationist Crybaby. And Creationist Crybaby's got a question for The Rock. Why did...
Actually, sorry, real quick. Sorry, scrolled a little further. We do have abernathite that has undergone radiometric decay. The oldest samples are about 2.4 billion years old.
Abernathite.
Yep.
There we go. That's how you say it. Very good. Okay, well, here we go. Creationist Crybaby, TRock. Why did God create the earth with all scientific indicators that it is 4.5 billion years old?
I just gave several very thorough scientific indicators that the Earth is not 4.5 billion years. I have not appealed to any non-standard physical processes, none whatsoever. I don't invoke miracles unless the Bible specifically warrants it. And so for most of the history that we can perceive in the rocks, there is no biblical reason to appeal to miracles. I'm appealing to standard physics. The magnetic field of the Earth does not scientifically indicate a 4.5 billion year old Earth. The ones that you think do, like radiometric dating, I've explained very thoroughly that zircons form with incompatible non-radiogenic minerals in them. And so it's purely biased to suggest that they form at a different time, or there's somehow no longer reasonable age assessors, simply by your bias that, okay, these formed when I think they did, and those didn't form when I think they did. Therefore, I'll pick the ones that I think did form properly. There are no true scientific consistent indicators that the Earth is 4.5 billion years old.
Okay, thank you very much, TRock. Any thoughts, Doc?
I'm good.
Okay. All right, we're gonna get one last question in there, I think, and then we're going to wrap up the debate as we are very close to the 3-hour mark. So let's see here. What do we have? Okay, here's a question from Iron Matt. Question for Doc. Is the radioactive decay rate always constant? And how can you prove such a thing?
As far as we can measure, it is essentially constant. If it is not absolutely constant, it's constant to within a few percentages, going by the worst estimates.
Thank you very much, Doc. TRock, over to you.
So for the sake of argument, I actually do assume, for the sake of argument, that the radioactive decay rates are constant for the duration of the history that we can discern, which is basically from the flood forward. We can't discern much before that. But I just assume, for the sake of our argument, that the radioactive decay rate is a constant. Nevertheless, it is a very valid question. We don't have a way of demonstrating that, but we do have a way of accelerating radioactive decay in a lab. So while I grant it as a given, and still hold to a very strong young Earth position, it is definitely warranted to ask the question, because you can't prove one way or the other.
Okay, thank you, TRock. Doc, you want the last word?
And I will still say it's sad that you can't accept results from experiments.
Okay. Yeah, that's 3 hours. So let's wrap it up there, gentlemen. I do appreciate your time, and I want to respect your time. So what we're going to do is wrap it up there. Excellent audience questions. I do appreciate all the feedback. And again, I appreciate all the on-topic questions that have come in. Doc and TRock. This was a lot of fun. It was comprehensive, as these debates should be. TRock's going to be here in September for an open mic on the ordering of the fossil records. So he's going to, as we usually do with these open mics, he's going to give a presentation, and then we're going to open up the mic for people to join and have some debate. Doc, he'll be back as well. We're just working out the details on a debate between he and Professor David McQueen on the global flood. So point is, both our awesome guests tonight will be back sometime probably in the next month. Okay, gentlemen, let's get some quick final words, final thoughts, if you'd like. TRock, why don't we start with you? Again, thank you so much for doing this. I appreciate your time. And final words, final thoughts.
Yeah, thanks, Doc, for joining the conversation. It was an interesting conversation. By and large, you're fairly easy to talk to. I would say, though, in the future, what I would like to invite you to is maybe sometime in the future, the next go around, you pick a paper from the secular literature that you think makes a particular point about something pertaining to the age of the Earth, or particularly the age of the Earth, but and then we can basically use that and go through it live and see what the secular literature actually says. For me, I'm thrilled to death to do stuff like that, because evolutionists offer up papers all the time, and I go read them, and they don't say what they suppose they do. And a lot of times I find very contradictory evidence to their position in those papers. So I'm always willing to invite somebody like yourself, get you a paper that you think makes a good case. Let's go over it live. And that way we're not talking about sources that we each other don't have. And I think it would make for a really good conversation. But thank you, Donny, for putting this together. Thank you. Big thanks to the audience for excellent Q&A discussion. And I'm really glad you guys tuned in.
My pleasure, TRock. I do love these debates. These debates are important as it brings in people with differing views and differing positions. It brings us in for these kinds of dialogues and discussions. So, Doc, over to you again. Thank you for doing this. Appreciate your time. And some final words, final thoughts.
Sure. First, thanks for having me. It was nice to finally debate you, TRock. I'm sorry I got a bit nasty there. That happens sometimes in certain situations. As for your stream idea, we'll see. Maybe someday. I am going to be extremely busy with work for the next while, and I'm working on another video in my free time. We'll see. Maybe eventually.
All right, Doc, thank you very much for the final words, final thoughts. Again, to our debaters tonight, TRock and Doc, thank you so much for doing this. This really was an awesome debate. I and the audience, we love debates on the age of the earth, a very comprehensive topic, and I'm really glad that we got to engage it for basically 3 hours. And so it looks like there is an after show / after party that Doc will be joining over on Mark Reed's channel. And so the link for that is posted all throughout the live chat. Please, for anybody interested in continuing the discussion, do click that link and check out the after show. And so we're going to wrap it up, everybody. Quick reminder, we'll see you again tomorrow night for our final debate of the summer, Carlos Xavier versus Pastor Kevin Tremblay. And then we'll be back on Friday night, 2 and 1. We'll be here all night as we usually are with these open mic debate showdowns. And so Evidence for Evolution, we hope all of our skeptics and non-skeptics will be there to enjoy this show with us. Okay, gentlemen, thanks again. And to the audience, thank you for tuning in.
Donny,
yes.
Sorry, quick question, and I apologize if I misunderstood something. Were we not transitioning here to an open mic?
No open mic tonight, just strictly formal debate. Your open mic is...
Oh, sorry. Okay. After that presentation. That's a kind of a one-sided deal, though, not a debate. No. Okay.
But before we shut it down, just for the audience sake, let me pull up my schedule. And so we can let people know when that open mic is. TRock open mic night is September 20th. So make sure to join all the skeptics, all of your biggest fans out there, TRock, those that want to debate you on your specific model, dealing with the ordering of the fossils. Make sure you're here for that. Again, that is September 20th. That's going to be a lot of fun for sure. And
so sorry, Donny, let me invite real quick the creationist as well, because me and you kind of had some conversation about this a little bit. The basic idea of peer review. Most of us are laymen, not professional scientists, but I'm inviting the creationist crowd. If you have a particular flood model that you strongly adhere to or that you think has good evidence, come prepared to talk about that in the open mic portion of it, because I would like your input on my particular version and how it compares maybe to what you believe to be true. And same goes for the skeptics as well. I mean, bring good arguments, bring good logical arguments, and be ready to talk about physics.
Well said. Both skeptics and non-skeptics are invited to the Fossil Record open mic on September 20th. Now, since Mark Reed is having an after show, anybody that wants to go engage in some impromptu open mic debate, make sure to check out his after show. And so with that, we are going to close things down for the night. Again, thank you for tuning in. God bless all. Standing for Truth is out.